Now, scientists have a wild theory. What if our entire universe is actually inside a black hole? This is called the black hole cosmology. Some scientists have the idea that our observable universe and everything we see around us might be tucked inside a black hole, which exists inside another parent universe or even multiverse. And then this multiverse could be part of a bigger one, and so on, kind of like a stacking doll. Sounds like pure science fiction, but this is based on some curious facts. When scientists create the timeline of our world, they say that everything started from a singularity. If you kept squeezing a giant ball smaller and smaller, at some point it would get super dense before it crushed. Well, it's hard to imagine, but in space, it's possible to squeeze a crazy amount of mass into a teeny tiny point. This point is called a singularity. The matter gets crushed into an infinitely small space, less than an atom, and it holds all the same mass of everything, while taking basically no volume. Inside this singularity point, things get so intense that the normal rules of physics just stop working. Everything we know – time, space, matter – breaks down and can't be applied anymore. Basically, what happens from now on is beyond our understanding. So, scientists say that this was the starting point of our world. When the Big Bang happened, it's like this tiny dot with everything inside it expanded to everywhere. This started forming the universe as we know it. And here's the thing. Scientists assume that singularity also exists deep within black holes. General relativity says that a black hole is born when something really big, like a huge star, collapses under its own weight. Gravity gets stronger the bigger the mass is. With a mass of a huge star, tens of times bigger than our Sun, this tiny point would have an unbelievable gravity. It's why it starts sucking in all the stuff around it and curves the fabric of space-time so much it looks like a hole in space. And this would be the center of a black hole. It's a dot where all these things fall into and get crushed into an infinitely dense point. So, could our universe itself be just a little singularity dot inside a huge black hole inside of another universe? Well, that would be wild. So, it's not that easy to compress something so much that it literally warps space-time. You'd need to squeeze it like crazy. If you wanted to make a small black hole, like a human size, you'd need to shrink them down to the size of an atomic nucleus. If you want a black hole the size of a chickpea, you'd have to compress our entire planet to that. But our universe is 99% empty space. There are trillions of miles of just nothingness between the stars. If you were to pack all the matter in the universe together, the result would be surprisingly small. Everything around us, including galaxies, stars, planets, and dust, would only fill about 1 billion cubic light-years. It would be a cube about 1,000 light-years on each side. For comparison, our Milky Way alone is 100,000 light-years in size. That's how sparse the universe is. But at this density, it would also be very, very massive. The resulting mass would likely collapse into a black hole. And here's the wildest part. The resulting black hole would be roughly the same size as the universe itself. It would also have the same mass and energy, as well as the same average density. The size or radius of the black hole grows together with its mass. The more stuff it eats, the bigger it is. But the density works the other way around. The black hole gets less dense as it grows. For a size that big of our entire world, it would be pretty sparse as well. And it's not the only coincidence. We have this thing called the Hubble radius, also known as the cosmological event horizon. If we imagine our observable universe as a giant bubble, then think of its edge like the farthest part of the universe we can see. When you stand in a field and look around, trying to see as far as you can, your eyes will draw a circle. This is like that. There might be more beyond that point, but we'll never know. Beyond this horizon, the light from distant parts of the universe will never reach us. That's because light travels at a certain speed, and the space between us and those regions is expanding too quickly. It's like running towards something while super strong winds try to blow you away. Until we stay on Earth, we're cut off from those far-off corners forever. The black holes have something eerily similar called an event horizon, or the Schwarzschild radius. This is the point of no return. This is the imaginary line that's often depicted as a light contour around the black holes. Anything crossing an event horizon, falling inside, is lost forever. No light, no matter, no information can escape from there. Black holes' gravity is way too strong, so they're perfect space vacuum cleaners. And as we mentioned before, if we create a black hole the size of the universe, they would have the same mass and the same event horizon radius. Now, while some scientists think this could just be random coincidences, others believe it's a clue that our universe might actually be inside a black hole. The theory also suggests that our universe might not be the only one. It could exist in one of many black holes scattered throughout a large multiverse. In this crazy model, each one of them, both in our world and our parent world, could lead to its own universe, with its own set of physical laws and structures. Now that would be some weird chain. There's this theory that says that universes could be born inside of black holes, sort of. It's called the Einstein-Cartan theory. This idea talks about singularity as well, but in a different way. It says that instead of collapsing into an infinitely dense dot, the matter might create a wormhole. This is like a tunnel through space and time. This wormhole, also known as an Einstein-Rosen bridge, could connect two different places of our universe. In that case, one side of the tunnel is the black hole, and on the other side, there would be a whole new universe forming. So it could work like a teleport. As soon as you pass the event horizon, you travel to the new world. But in that case, there should be an exit. Some scientists made it up and called it a white hole. It doesn't literally exist, not as far as we know, but it could be possible somewhere on the other side. It would serve as an exit of a wormhole, an area where matter is always ejected instead of pulled in. So it's like you can't throw anything in there, it would get expelled immediately. That's all purely hypothetical, of course. All this stuff fits well into the concept of the Big Bounce. This idea says that instead of our universe beginning with a singular Big Bang, it bounced from a previous state of collapse. Remember the squeezed ball analogy? Well, maybe there used to be another universe ball that got super compressed to a minimum size before rebounding and expanding again. So instead of a universe born from nothing, we might live in one that's a cosmic recycling of another. There's also another version of this theory, sometimes called shockwave cosmology. The idea says that the Big Bang could have been caused by a boom inside a black hole, and this could create the expanding universe we see today. As the universe expands and the matter density decreases, the black hole would eventually transform into a white hole, the reverse of a black hole, where matter is expelled instead of pulled in. But even though we have all these interesting connections, they're not evidence. There are no experiments or observations that could prove or disprove these wild theories. So they all remain speculation for now. But at least it's fun to speculate.
Usually, when we look at the photos of astronauts in space, we can see that they're sort of attached to the spacecraft. But there was one brave astronaut who took a wild step into the great unknown without any safety line connecting him to the shuttle. This brave man was Bruce McCandless, and he did that stunt back in 1984. How did he come back, you may ask? He did this cool trick using a nitrogen jetpack, which NASA called the Manned Maneuvering Unit. At first, he tried out some test maneuvers in the Challenger's payload bay, and only after he made sure it was all right did McCandless decide to go for it and glide a staggering 320 feet away from the shuttle. A bit of sad stats here. Out of the 430 people who have made the leap into space, 18 have sadly lost their lives, which gives us a fatality rate of just over 4%. With these numbers, it's safe to say that space shuttles are the least safe means of transport out there. Duh. Alright, let's make it a tad brighter. If we crunch the numbers a bit better, we can get a smaller percentage. But how? Well, 4% is a bit misleading because when we count, we take all the space flights. However, Some people flew several times, which reduced the probability. With over 600 seats filled across 113 shuttle flights, the true fatality rate for shuttle missions is actually closer to 2%. Let's test your general knowledge now, shall we? So, what was the first living thing ever sent to space? If your answer is a monkey, you aren't right. Those who said dogs, sorry you guys, but it's not correct either. On the 9th of July 1946, fruit flies became the first living creatures to make it to space during a suborbital V-2 rocket flight. Then, on the 20th of February 1947, these little guys safely returned from their journey, opening the door for future human space exploration. Before, we sent to space mammals like the rhesus monkey, Albert II, in 1949, or the famous space dogs. Scientists spent a lot of time studying fruit flies to see how they reacted to radiation and the conditions of space travel. Researchers started using fruit flies for experiments back in the 1910s. Guess why? Because we humans share a lot of genes with these yucky pests. Imagine hearing some creepy music all of a sudden when there's nothing but darkness around you and nobody is there to help you. Right, now imagine how elevated this experience was for astronauts who heard some creepy music in their space shuttle. Months before the moon landing, Apollo 10 astronauts were orbiting the moon, testing equipment, when they heard strange audio noises. Astronaut Eugene Cernan noted the eerie sounds, joking they were like weird music. At that moment, the astronauts didn't have contact with mission control. They were over the moon's dark side. Although the noises resembled something from a sci-fi film, NASA downplayed them as they were focused on the astronauts' mental health. Despite years of speculation, the source of the sounds remains unknown, with theories ranging from radio interference to charged particle activity. Cernan later remarked that they didn't take it seriously and didn't report it after the mission. Chances are, we've already received messages from new friends from other galaxies, but we just failed to understand them. In August 1977, some astronomers using the Big Ear radio telescope at Ohio University picked up a strange narrow-band radio signal from the constellation Sagittarius that lasted for 72 seconds. The signal buzzed at a frequency of 1,420 megahertz, which is significant because it matches the natural emissions from hydrogen. This frequency had been flagged by scientists almost 2 decades earlier as a likely choice for extraterrestrial civilizations trying to reach out to us. They dubbed it the WOW signal after one of the astronomers wrote "WOW" on their printout. We've never heard that signal again, and no one has been able to explain its origins satisfactorily. After spending about a month in space, astronauts start losing quite a lot of skin from the bottoms of their feet, especially those tough calluses they've built up over time. One astronaut even called Mission Control in a bit of a panic when he noticed a chunk of his heel drifting off in zero gravity. But no worries, as the old calluses peel away, new ones spring up from the tops of their feet. They need that grip to hold on to all the restraints, kind of like airborne trapeze artists. Going number 1 and seeing blood is as scary as it sounds, and yes, in the weightlessness of space, blood doesn't settle in the lower body in the same way it does on Earth. This can lead to some alarming situations on board. Natural urges are universal, regardless of location. There are 2 main reasons why astronauts are unable to use traditional toilets in space. First, water is an extremely valuable resource aboard a spacecraft. Second, there's no gravitational flow of water in space. The drinkable water on a space station is contained in pouches and is used accordingly. In a weightless environment, a specialized device with suction and disposable bags is used for waste collection, with the storage being replaced every 10 days. Additionally, spacecraft are equipped with complex systems designed to recycle and filter liquid waste, converting it back into usable water for the astronauts' daily needs. As if that wasn't enough, spending an extended period floating around in space brings another challenge. The body may lose its bursa sacs, those handy little cushions that sit between our hip joints. While this may not pose an immediate issue in the zero-gravity environment, returning to solid ground can turn the simple act of sitting down, whether in a chair or on a toilet, into a real struggle. The fluid shifts that contribute to blood-related issues don't stop there. They can also wreak havoc on astronauts' sinuses, creating a constant feeling of congestion. It feels like living in a stuffy room all the time, where relief seems just out of reach. Thus, the challenges of long-term space travel add up, making the experience as daunting as it is thrilling. Another challenge astronauts run into is vision loss, also known as ocular syndrome, which sounds all sciencey. While the exact cause is still a bit of a mystery, it's thought that extra pressure on the brain can mess with both the retinas and optic nerves. And here's a fun fact: it mostly affects guys. By the way, you might assume that shutting your eyes in space means it's pitch black, but that's not the case. Because of high levels of radiation, astronauts can still see bright lights when they zip through certain parts of their orbit. It's a pretty strange phenomenon that keeps them on their toes, even with their eyes closed. Switching gears, let's talk about bone health in space. It turns out that being weightless can really take a toll on astronauts' bones. Like, they can lose up to 2% of their bone mass every month, which is pretty wild. But the good news? They've come up with new exercise routines that help fight off that bone loss. So, while space travel definitely has its challenges, researchers are working hard to keep astronauts in tip-top shape as they explore the universe. The Big Crunch is a cool theory about how the universe might end, and it's basically the opposite of the Big Bang. So, imagine the universe expanding for ages, but then it hits the brakes and starts collapsing in on itself, maybe even forming a huge black hole. Scientists are looking into this by checking out the universe's density. If it's too dense, such a collapse might really happen. At first, people thought that gravity would eventually take over and stop the expansion from the Big Bang. But then we found this mysterious thing called dark energy, which is actually speeding up the universe's expansion. Because of that, it seems like the Big Crunch is pretty unlikely. Right now, the evidence shows that dark energy is here to stay, so the universe will just keep on expanding forever. Let's say a spacecraft runs out of power far in deep space. It wouldn't fall in the traditional sense because there's no gravity. Newton once said that an object remains in motion unless acted upon by an external force. In our case, this external force is gravity. In other words, if there's nothing with gravity around, it would continue to move due to inertia. It would keep going the way it did, without us being able to change its trajectory or adjust it in any way. It would keep traveling through deep space, almost forever. Well, at least until radiation and cosmic rays destroy it. And unless some celestial body like an asteroid doesn't destroy it either. And of course, unless it encounters something with a gravitational pull, like a planet or a star. The likelihood of all this depends on the location and trajectory of the spacecraft. Voyager 1 was launched by NASA in 1977. It's been on its journey for almost 50 years now. Right now, it's the farthest human-made object from Earth, more than 50 billion miles away. It's already very far from all our planets, and it's the first spacecraft to enter interstellar space, the vast, empty space that exists between stars in a galaxy. It's the space outside our solar system, where there are no planets, moons, or other objects associated with our Sun. However, it's still in our solar system. To leave it, Voyager 1 needs to bypass the Oort cloud, a big, icy collection of objects where all the comets in our solar system probably come from. It will take Voyager about 300 years to reach the inner edge of the cloud, and then about 30,000 years to bypass it. Voyager 1 has a special plate on board, like a message in a bottle. This plate is called the Golden Record. It's not really golden, it's actually a shiny gold color. On this plate, there are things that tell a story about Earth. It was created in case Voyager ever encounters any extraterrestrial beings. The record has greetings in different languages, music from Earth, and even the sounds of nature, like birds chirping and the wind blowing. As the distance between us increases, the signal strength from Voyager 1 weakens over time. Eventually, it may become too weak to be detected by our communication equipment. The power output of Voyager 1's engine also declines over time. It's slowly running out of fuel. When all its systems shut down, we will lose contact with the spacecraft. Voyager 1 will work until 2025. After that, it will continue its journey on inertia. Luckily, it was designed to last, and the chance that it will encounter anything on its way is very small. Considering this, it might even keep going for billions of years. One day, it might even reach other star systems, and maybe even outlast our Sun. The same goes for Voyager 2. It will keep traveling until it reaches interstellar space, joining its twin brother. Voyager 2 will continue to send us scientific and systematic data for a while, even in interstellar space. However, it will also cease to function eventually, becoming a silent artifact drifting through the Milky Way. When there's something with gravity near the spacecraft, the inevitable happens. It falls onto that object. This is why out of the vast South Pacific Ocean beyond New Zealand lies a unique and intriguing place known as the Spacecraft Cemetery. Officially, it's called the South Pacific Ocean Uninhabited Area. It's located near Point Nemo, the most remote spot from any island. It serves as the final resting place for spacecraft that have completed their missions and reached their lifetime limit due to wear and tear. Sometimes, these larger spacecraft are too hefty to burn up during re-entry into Earth's atmosphere. In that case, they're directed to crash or splash down in this remote ocean location. This helps protect us from any potential harm during re-entry and impact. There are, however, some big problems with this place. Scientists are worried about the impact this spacecraft cemetery has on the ocean. When spaceships come back to Earth, they often spill chemicals. One of these chemicals is hydrazine, a dangerous rocket substance. Unfortunately, it might not completely burn up during re-entry, so it leaks out into the ocean, posing a threat not only to marine life, but to us as well. We made up some rules, both within countries and internationally, to stop this. However, it's not easy to figure out how risky it is for certain spacecraft to enter the cemetery. We can't say for sure how much of a substance is left after it enters the air. As for spacecraft that don't fall, they're often left in space as debris. This is what we call any man-made object orbiting Earth that's no longer useful. It's also very dangerous. There are over 27,000 pieces of space debris orbiting Earth at high speeds. All this puts human and robot missions at risk and harms spacecraft. As we mentioned, usually we get rid of space debris by trying to bring the crafts back to Earth. This makes them burn up when they re-enter due to high speeds and air pressure. This usually works with smaller objects. There are also riskier methods, like letting spacecraft break down themselves, or crash into other things, or blow up. These methods aren't great because they just make up even more debris, even if it's smaller. So now, scientists are trying to find new ways to get rid of retired spacecraft. For example, nets and magnetic arms. There's also a thing called reusable spacecraft. It's a space vehicle that's built to be used more than once. For example, space planes such as the Space Shuttle and the Dream Chaser, or capsules like the SpaceX Dragon. They're designed to launch, orbit, come back to Earth, and do it all over again. But it's important to make sure these spacecraft and their passengers or cargo stay safe during the return, which is quite hard to do. Reusable spacecraft have special systems to guide them back to Earth safely. The Space Shuttle, for example, had OMS pods, sort of special backpacks that help the spacecraft move and control its position in space. The SpaceX Dragon had its own engines to slow down and enter the atmosphere in a controlled way. They also have a heat shield to protect it during re-entry. The heat shield can be made of different materials, but they need to be tough and able to withstand multiple trips. Coming up with a heat shield that's both strong and lightweight is a bit of a challenge. Finally, if a spacecraft lands on a runway, it needs wings and landing gear. They also add weight. Some designs like lifting bodies or the delta wing of the space shuttle try to reduce the mass of these parts. After landing, the spacecraft might need some fixing up before it can go on its next adventure. This process can take a while, up to a year, and it might not always be possible to use the spacecraft again if it's been fixed up. There's also a limit to how many times a spacecraft can be fixed and used again before it has to retire. Different spacecraft have different abilities to be reused. Finally, sometimes we can rescue a spacecraft or even remake and repurpose it. Voyager 2 is one of the examples. It had a little trouble with its radio in 1978. Engineers fixed it by using a backup system. Since then, it's been exploring our solar system for over 40 years. The Hubble Space Telescope is the most famous telescope we have, the grandfather of them all. However, it had a blurry start in 1990. The work wasn't done at all as expected. The pictures were of low resolution. Luckily, astronauts fixed it right in space in 1993. To do that, they used some corrective mirrors. Now it gives us fantastic views of the universe. As you can see, even in bad scenarios, there are many possible options to solve spacecraft-related problems.
For decades now, people have been dreaming of exploring space. And since the year 2000, there has indeed been a continuous presence of people in space. And recently, a new record has been set. Just a couple of weeks ago, there were 17 people from 5 different countries in Earth's orbit at the same time. The previous record was set in September 2021 during the privately funded Inspiration 4 mission. At that time, the number of people in orbit reached 14. So let's see. Just recently, 3 more people have arrived at China's Tiangong space station. There were 3 more astronauts aboard the same station, but they've been there since November 2022 and are supposed to return back to Earth in June. Then there are 7 people on board the International Space Station, and 4 more departed the ISS aboard SpaceX's Crew Dragon named Freedom. They successfully returned to Earth on the 30th of May 2023, leaving 13 people in orbit. Interestingly, the current record also includes the 600th person to get into Earth's orbit. Specialist Rayana Barnai from AX-2 mission became a space traveler number 600, as well as the first Saudi woman in space. But I've got something even more exciting to tell you. Oh my! The record for most people in space, and just not in Earth's orbit, was reset not so long ago too. But it lasted for a mere 5 minutes or so. But during this short period of time, there were 20 people off the planet. This record was set when 6 members of the Virgin Galactic Unity 25 Spaceship Two crew happened to be in space at the same time as 3 Chinese taikonauts living and working aboard Tiangong and 11 astronauts on board the International Space Station. Now, that's getting crowded. Well, the International Space Station has always hosted the majority of space travelers from Earth. But I bet there are some cool facts about this marvel of technological development you haven't heard yet. The ISS is the 3rd brightest object in the night sky, and the coolest thing? You can sign up for a special service and you'll get a text every time the ISS travels over your location and is visible with the unaided eye. I've seen it dozens of times myself, and it's very, very cool. Normally, you can see it between dusk and dawn, but be ready because the station is very fast. It moves at a speed of 5 miles per second and circles our planet every 90 minutes. The International Space Station is a true record breaker. It's the largest human-made object in space. It's 357 feet long from end to end, which is about the same length as a soccer field. It also weighs about 450 tons. 8 spacecraft can dock at the ISS at the same time. The working and living space of the station is bigger than a 6-bedroom house. Astronauts have 6 sleeping quarters, a gym, 2 bathrooms, and a beautiful 360-degree view from their special bay window. Now to the nitty-gritty. On the ISS, you wouldn't have to deal with lots of disgusting smells. there is a specially trained person who smells everything astronauts take with them in space. It's done to protect them from unpleasant odors. The thing is that you can't really air the room out there if you don't like how it smells inside. That's why NASA is very careful about what kinds of smells are allowed to pass through. You'd also have to get rid of your clothes instead of washing them after each use. To bring a mere 1 pound of load to the International Space Station costs up to $10,000. That's why it's easier to throw your clothes away when they get dirty than to waste water washing them. Now, while sleeping, you'd have exceptionally good airflow around you. Otherwise, the carbon dioxide you'd exhale would form a bubble around your head and you get oxygen deprived, and that's not good. Now, people often think that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon can orbit Earth and the Sun doesn't float away from our home Milky Way galaxy. But astronauts on the ISS experience not full-fledged but microgravity, which means itsy-bitsy gravity. Earth's gravity on the space station is not only around 10 to 12% weaker than the gravity on the planet's surface, but astronauts are constantly in free fall. The spacecraft, the people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. But our space exploration plans are much more ambitious than just orbiting our planet on board the ISS. We're planning to send a mission to the Moon and build a colony on Mars. Some experts claim that in the next 25 years, around 20,000 people are likely to leave Earth. But how many people would it take to colonize an entire star system? In 2002, anthropologist John Moore from the University of Florida stated that a spaceship with 150 passengers could leave Earth and set off on a several thousand years journey to another star system. And upon arrival, the descendants of the original crew could build settlements in a new world. That seems like a lot of work to me. Let's continue. The nearest star system, Proxima Centauri, is 4.2 light-years away from our home planet. Talking about space is just next door, but for us, it's so far that we would need to build a generational spaceship to get us there. But the question is how many people you'd need to send on such a mission to have enough genetic diversity. A new study disagrees with John Moore, claiming it must be way more than 150 people. According to a scientist from Portland State University, a spaceship traveling to such a distant world would have to carry at least 10,000 people. This number might secure the success of the mission. 40,000 people would be even better. Who knows what could happen to the travelers during such a challenging and unprecedented journey? At the moment, NASA isn't ready to send humans even to Mars, let alone a distant solar system. But a few private organizations are working on this project. They hope to make interstellar trips possible in the next century. They count on a huge increase in propulsion speed, which could potentially reduce the travel time between stars to a mere few hundred years. Researchers have built several simulations to figure out how many various scenarios could play out during such an interstellar mission, and they have come to the conclusion that the success of this mission would greatly depend on the size of the starting population. Genetic diversity would keep the travelers healthy. The larger the population is, the more diversity it has. And 150 people is definitely not enough to maintain genetic variations. Even a population of 500 people wouldn't be sufficient enough. At the same time, if we sent to another solar system 40,000 people, we'd be able to maintain 100% of the variation. Even 10,000 travelers would make the scenario relatively stable, which means that any number between 10 and 40,000 people would be a pretty safe bet. But of course, we wouldn't be able to send so many people in space in just one spaceship. We'd have to build many and spread people among them. These ships could be modular, able to dock together for trade and some social gatherings, for the genetic variety, I'm guessing. But they would travel separately, so that if some disaster struck one of them, the rest would remain unharmed. But to make interstellar travel possible, researchers and engineers will have to overcome loads of obstacles. We still need to increase propulsion speed, deal with the negative health effects of living in space, and invent self-sustaining systems providing air, water, and food. Or we could just decide to fix our own planet and stay home. Does the universe ring like a crystal glass? Maybe. But it doesn't mean that it literally rings and we just don't hear it. It just vibrates. Many of you know that the universe started with the Big Bang around 13.8 billion years ago. I wasn't around then, but we can assume. The whole enchilada was born from a super concentrated, hot, and dense tiny dot that contained everything. When it couldn't bear its pressure anymore, it made a huge blast and spewed around all the time, space, matter, and antimatter like a Pokeball. After being born, the universe moved at a breakneck speed. Imagine standing in the middle of nowhere, you blink, and suddenly you're surrounded by the universe. That's what it would feel like. It started growing and growing, and eventually, its speed got slowed down a bit by gravity. Gravity started pulling all the matter together, slowly helping new things like stars and galaxies to form. Okay, makes sense so far. The Big Bang gave the universe a big push, accelerating it. Logically, everything should eventually slow down and start moving at a constant speed, or even stop, right? Well, nope. In the late 90s, astronomers discovered something weird. They looked at some supernova around us, and for some reason, these supernovas were super far away, much farther than they were supposed to be. In other words, the expansion of the universe is not only continuing after all these years, but it's even accelerating. After years of study, they discovered the concept of dark energy, a mysterious force that makes up about 68% of the universe's total energy. This energy pushes it to expand even faster over time. And now, scientists have proposed a new discovery. Perhaps the universe's movements are a bit, well, wobbly. It seems like the universe's expansion hasn't been smooth and stable over the years. Instead, it has undergone periods of speeding up and slowing down multiple times. Astronomers counted about 7 cycles of this acceleration and deceleration over the history of our universe. This can be compared to the oscillation of a crystal glass. When you strike a crystal glass, it vibrates, oscillating at its natural frequency. It goes through fluctuations in which the frequency rises and falls. Over time, it calms down and fades away. Well, something like this is happening to our universe. You can imagine its speed also fluctuating like that, rising and falling, first super rapidly and then more calmly. As if it's not just different waves traveling through it, but our entire world is like one huge ringing wave. The discovery was actually made by accident. Astronomers were working on dark matter modeling. They plotted a new graph called the Hubble diagram, which shows how big the universe got over the years, measured in supernovas. Supernovas are like some lighthouses of our world, helping us mark things on a map. That's when they found these oscillations. But we still need to check all the data to make sure that this discovery is indeed true. Dark energy and dark matter play this weird game with the universe, where one is constantly trying to pull everything together, while the other one wants everything to expand. So far, dark energy vastly outweighs dark matter, whose weight makes up only 27% of the universe. Now, both of them are invisible to us, and not just invisible to our eyes like infrared, it's that we literally can't detect them in any way. We can only assume that they exist based on how they influence gravity, changing entire galaxies, and all the large-scale structures of the universe. We basically made them up because it was the only way to explain how our world works. Dark energy is uniformly distributed across space and time, and we're still not sure what exactly it is. Some theories say that it could be a property of space itself, quantum fluctuations, or even a new type of field or particle. But all we have for now is an invisible energy that pushes the universe to move very fast. If one day we learn more about it, this will help us predict the entire fate of our world. Depending on how exactly dark energy works, the universe may continue expanding and growing indefinitely. Or maybe one day, it will experience the Big Rip, where all matter will be completely torn apart. Okay, here's to hoping we're not all around for that. Meanwhile, dark matter, also invisible and yet to be proved, works the opposite way. It's not energy that accelerates things. Instead, it's more like a glue that tries to hold everything together. It's a type of matter we can't detect because it doesn't emit, absorb, or reflect light. We don't even know what particles make up this thing. We still can't catch them. At first, we thought it might be made up of regular heavy particles, like the one that makes up our world. But after years of research, they haven't found even a single one. So now they think maybe it's actually made up of ultralight particles, millions of times lighter than anything we know, and because of that, we can't even notice them properly. So now, astronomers try to detect not the particles themselves, but waves that they could leave as they move through space. But we believe that it exists, because if it didn't, our galaxies wouldn't hold together. Dark matter helps them form, grow, and rotate. So, about 85% of our world is made of something unknown. All of this is incredibly mysterious and needs a lot of research. But that's what we know now. Maybe in the future, we'll discover something that will completely change our perception of the universe. That's what happened to Albert Einstein. In the early 20th century, most scientists, including Einstein, believed that the universe doesn't actually move. They thought it was static, neither expanding nor contracting. That's because, to us, it feels like it doesn't really move. Back then, scientists didn't have powerful computers or telescopes that could detect all the little changes in the positions of stars and supernovas. When Einstein developed his famous general theory of relativity in 1915, his equations actually suggested that the universe should either be expanding or contracting. This didn't really make sense to him. To fix this calculation flaw, he decided to introduce a new term, the cosmological constant. It was like a repulsive force that counteracted the attractive force of gravity. Essentially, it meant that while gravity tries to push everything together, some force or energy helps to balance this out by pushing everything apart. Sounds familiar? Then, in the 1920s, astronomers Edwin Hubble and Georges Lemaitre found out that the universe isn't static, it actually expands. They noticed a slight reddish tint from the distant galaxies, and this tiny hint meant that other galaxies were moving away from us. After that, Einstein scratched out the cosmological constant. Interesting how he was later ashamed of this assumption, calling it his greatest blunder. He didn't even know that he was 100 years ahead of his time, accidentally discovering dark energy. Now the cosmological constant is back again, just in a new form. Something similar happened with dark matter. Scientists have already started noticing that something doesn't add up back in the early 20th century. They saw that galaxy clusters didn't have enough visible mass to hold them together, which means there must be some unseen mass that helps to make up for it. And that's when it got its name, the dark matter. This stayed unresolved and unproven for many years. And then, it was finally discovered by Vera Rubin when she was observing galaxies and their movement. She realized that outward parts of galaxies move almost as fast as their central parts. This doesn't really make sense. The outer parts should be a bit slower. This became the first official proof of dark matter, which boosted its research. There are still many things left to be discovered, but maybe one day we'll understand what is this invisible part of our universe that makes it ring.
Many sci-fi movies can make you believe that everything happening in space is accompanied by some kind of sound effect, which is a totally false misconception. In space, no one will hear you scream. There's no air in space. It's an almost perfect vacuum. And the sound waves don't travel through a vacuum. They can't reach your eardrums and make them vibrate, sending signals to your brain. But it's a good thing, especially for astronauts on spacewalks. If not for the quietness of space, they would be constantly overwhelmed by the noise of solar storms. Huge space explosions sure look super impressive. Whether they're scientifically possible or not is another question. Blasts on our home planet look the way they do because of air and gravity. You see, the air functions as an oxidizer, and the outward pressure makes everything fly into the air and then collapse back to the ground. But this process is very different in space, and it looks even cooler. If a blast occurred in space, there would still be some fire despite the lack of air, because some kinds of fuels can act as oxidizers. But it wouldn't be the fire you're imagining now. This cosmic fire would look like an expanding ball of light. It would be a seemingly never-ending process due to microgravity and the lack of air resistance. Nearby spaceships would be in grave danger since the shrapnel would fly outward until something eventually stops it. All comets have beautiful long tails. Huh? It's nothing but a popular misconception. In reality, comets are very difficult space bodies to spot. They usually spend large amounts of time far away from stars. There, in the darkness of space, they remain rather inactive and completely frozen. Comets only get tails once they come close to a star. That's when they start warming up. This process makes them form some kind of a cloudy atmosphere, which is called a coma, and a distinctive tail. The tail always points away from the star that influences the comet. It happens because the tail gets blown in the opposite direction by solar radiation and solar winds. That's why the tail can often be in front of the comet, not trailing after it. The inner and outer planets of the solar system are separated by the asteroid belt, a ring of asteroids and other debris and space objects orbiting around the Sun. While creating movies about space, filmmakers make sure to somehow use this region. Usually, they show the asteroid belt as an extremely crowded place with dense clouds of huge rocks you have to skillfully maneuver to get through to the other side. In reality, if you looked outside your spaceship while flying through this region of space, it would feel as if you're looking at the sky from Earth. All because of the ginormous distances in space. If you decided to cross the asteroid belt, there would be very little chance of a collision with a space object. Asteroids there are really spaced out and very far from one another. Black holes are giant, scary cosmic vacuum cleaners, they say. But in reality, black holes are more like fly traps. They don't look for things to munch on. Instead, they sit out there quite passively. Only when a star or any other object comes too close does a black hole spring into action. Even so, only those space bodies that cross a certain border get ripped apart. In fact, black holes aren't any different from any other celestial body since their pull is directly proportional to their mass. They can't swallow anything bigger than what their size allows. Even if our Sun was somehow replaced with a black hole as massive as itself, nothing would change for Earth or any other planet in the solar system. Gravitationally speaking, of course. Space battles in movies often involve using lasers. But if you were to see such a fight from up close, you would probably be disappointed. The thing is, it would be like nothing in movies. A laser beam is a concentrated burst of energy, and it could indeed be used for many purposes during a fight. But a real-life laser beam would be totally invisible in space since there wouldn't be any particles around to scatter the light and make the beam bright red or green or any other color. A human would be torn into pieces if they got into open space without a spacesuit. Well, contrary to popular belief, taking off a spacesuit during a spacewalk wouldn't be as dramatic as it's often pictured in movies. A person would just lose consciousness due to a lack of oxygen after 15 seconds of being in outer space without protection. But that's if this person breathed out as much air as possible. Otherwise, this oxygen would damage their lungs from the inside, making them rupture. After that, without the protection of the spacesuit, the pressure inside their body would drop. This would cause even more serious trouble. And even though this person definitely wouldn't burst, they wouldn't want to stay outside for too long. People often believe that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon orbits Earth and the Sun doesn't float away out of our home Milky Way galaxy. Astronauts on the ISS do experience the effects of gravity, but that's not full-fledged. It's microgravity. The gravity on the space station is only 10% weaker than the gravity on Earth's surface, but astronauts are constantly in freefall. The spacecraft, people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. That's why astronauts can move things as heavy as hundreds of pounds with their fingertips. And even though microgravity is often called zero gravity, they are very different things. A light year must mean time, right? Not really. Light years actually measure distance. NASA's definition of a light year goes like this: the total distance that a beam of light moving in a straight line travels in a year. And since light moves at a speed of 186,000 miles per second, a light year equals almost 6 trillion miles. It may seem as if the sun is always on fire. At least that's what it looks like in pictures and in movies. But in reality, our star is a giant ball of gas. Nuclear reactions happening in its core at all times make the sun burn. Every second, hundreds of millions of tons of hydrogen are converted into almost as much helium. During this process, huge amounts of energy are released as gamma rays. Then these rays turn into light. In other words, the sun does emit blinding light and incredible heat, but it's not actually on fire, because no oxygen is involved in the process. The speed of light is believed to be the ultimate barrier for people when it comes to space travel, and it's often thought to be impassable. There are many theories about what it might be like to reach that speed, but none of the equations account for going above it. And still, we know that at least one thing in the universe is faster than the speed of light: the rate of its expansion. Yep, the universe is expanding faster than the speed of light, baffling astronomers and casual sky watchers alike. Or at least we can say so in terms of the speed of different objects, like faraway galaxies relative to each other. At the moment, it's not something scientists understand well. The rate of the expansion of the universe is proportional to how far something is, too. The farther it is from us, the faster it's moving away. But even though we don't get the mechanics of it yet, we've got our proof, even though it's theoretical so far, that some particles might be able to travel faster than the speed of light. Some scientists think there could be more things out there in space that could challenge this speed barrier. All we need to do is find them. In April 2023, astronomers found something exciting: a runaway black hole. This thing is moving through the universe at an incredible speed, about 3.5 million miles per hour. It's 4.5 thousand times faster than the speed of sound. They found it accidentally. Researchers noticed that there was some weird straight line in Hubble images. After some digging, they realized there was a moving black hole. As it moves, it compresses the gas on its path, literally creating new stars along its journey. So it's leaving a beautiful, long trail of stars behind it. And when I say long, I mean it. Its tail is 200,000 light years long, which is like the length of 2 Milky Ways. Turns out one end of this star trail connects to a distant small galaxy. This is probably where the black hole came from. Most likely there were 2 supermassive black holes whirling around each other. And then another galaxy came along with its own supermassive black hole and ejected one of the original ones like a mean kid, which is why it's called Runaway. There might be a 9th planet with the very original name, Planet 9, in our solar system. If it exists, it's probably somewhere far beyond Pluto. Astronomers think so because some rocky objects near Neptune move in a weird way, as if they were influenced by the gravity of a large, unseen planet. Planet 9 might be a gas or ice giant 7 times the mass of Earth. One of the ideas is that it could have existed in our solar system, but then bumped into something huge and ended up with a crazy long orbit around our sun. If we actually discover it, it could change our understanding of the solar system. A new telescope is coming soon. equipped with the largest digital camera ever built, and it will start scanning the sky in 2025. Maybe it will finally spot this mysterious planet. Another awesome discovery was made in 2023. The James Webb Space Telescope found over 500 planet-like objects in the Orion Nebula. Some of them are roughly the mass of Jupiter, so they're literally called Jupiter mass binary objects, or jumbos. They just float out there with no stars, and they're not really stars or planets themselves. What's even crazier is that in about 42 pairs of them, the objects are orbiting each other, even though planets aren't supposed to do that. On top of that, such large objects shouldn't form and exist without a star at all. So now, astronomers are trying to explain this. Perhaps jumbos have formed in places where there was enough stuff for big planet-like objects, but not enough for stars? Or maybe all of them were ejected from their star systems for some reason. Who knows? But now we definitely need to study them. The black hole in the center of our galaxy, Sagittarius A star, used to be super weird. Luckily, it didn't run away like that other one, but it was completely crazy in the past. Astronomers found two supermassive structures called the Fermi bubbles and eROSITA bubbles. They spanned about half the width of our entire galaxy, and they've been towering over the Milky Way for over 2 million years now. And scientists think that it's our black hole that created them. It seems like when it was at its peak activity, it had a wild, energetic eruption that lasted about 100,000 years. This event probably left these bubbles. In 2023, the James Webb Space Telescope took a striking, super detailed image of the so-called Herbig-Haro objects. These objects are called Herbig-Haro 46/47. They're basically young stars surrounded by beautiful patches of nebulosity. You can see the stars being surrounded by a disk of material that feeds them as they grow for millions of years. They're located at about 1,470 light-years away, but they're actually not our main topic of discussion. What's much more interesting is this weird thing right below them, a space structure that looks like a question mark. What is this thing? No one knows for sure. It has an orange-red color, which hints that it might be super distant, far from our galaxy, maybe even billions of light-years away. Some think that this strange question mark is probably the result of two or more galaxies merging together. One of them was a bit curved, so it's probably a distorted spiral galaxy. The curve might be the tails being stripped off as they spiral towards each other. The other one was rounder and smaller, like a regular spherical one. The gravity games never fail to amaze us. Astronomers started searching for extraterrestrial megastructures. They think that if there's another intelligent civilization out there, they could have built something incredibly huge to power their technology. For example, like Dyson spheres. Hypothetical structures around stars that use the star's energy as fuel. Astronomers analyzed some historical telescope data that detects infrared signals. They spotted some weird signals that could hint at the presence of these structures. In total, there are 7 such candidates right now. All of them are coming from red dwarf stars, which are redder, smaller, and less massive than the Sun. Another research institute found 53 potential candidates. They're still not sure what exactly causes these signals, but it could be not Dyson spheres, but some huge debris. It looks like there are some mysterious structures in the center of our galaxy. In 2023, the James Webb Space Telescope has taken a detailed picture of the Sagittarius C region. It's right near the center of the Milky Way. This image showed a dense area where stars are forming. There were many young stars and dark clouds that blocked the light from the stars behind them. That's a very packed place, with about 500,000 stars of different ages, sizes, and colors. This place is very chaotic and extreme. Now, scientists are using it to study star formation. But the weird part is that they noticed something else, the large region of ionized hydrogen. It looks like cyan in the image. This area is about 25 light-years long, surrounding the lower side of dense cloud. And it looks like there are some needle-like structures. They seem to be located randomly, and astronomers have no idea what they are. So now they have to study this in more detail. Astronomers have found a super rare massive galaxy. It's called JWST 7329, and it's absolutely ancient. Our entire universe is about 13.8 billion years old, but the stars in this galaxy seem to have formed around 13 billion years ago, so just around 800 million years after the Big Bang. Also, this venerable elder has 4 times more mass in stars than our Milky Way does today. This strange discovery challenges what we know about galaxy formation and the nature of dark matter. Everything we know tells us that galaxies shouldn't have formed so early. There shouldn't have been enough dark matter for that, but here we are. So, perhaps our models need some revision. There was an incredible astronomical event called AT 2021 LWX, which is also called Scary Barbie. It was an unbelievably bright burst of energy that happened on April 13, 2021. It's one of the most energetic space events ever observed. No galaxies or quasars were nearby, so what in the world happened? At first, astronomers thought that it was caused by a supermassive black hole pulling in a massive star. But after some studying, they think it's probably because a giant black hole had some crazy dinner. It probably ate a large amount of gas, possibly a giant molecular cloud. The titanic black hole in question is between 100 million and a billion times the mass of the Sun. This is one of the most massive known and active black holes. Astronomers found the oldest strand of the cosmic web ever seen. The cosmic web is what we call a huge structure of the universe that's made of interconnected filaments of galaxies and dark matter. They're like a framework for galaxies and other structures, playing a crucial role in their formation. The filament we're talking about is made up of 10 closely packed galaxies. It's unimaginably huge, stretching over 3 million light-years. And it looks like the newly discovered strand is very ancient. It occurred only 830 million years after the Big Bang. It's probably anchored by a luminous quasar. This discovery makes us question how exactly galaxies are formed and what exactly happened to our universe after the Big Bang.
Ruh-roh, there might be another universe, like a dark mirror image of ours, where time flows in reverse. This flipped-over world might also be the source of dark matter, the invisible substance that's all over our universe. There might also be many more universes out there, in which an exact copy of you woke up this morning, but it chose a white t-shirt instead of a red one, sending it on a completely different life path. But let's start with this elusive dark matter. It makes up most of the universe's mass, yet we're not sure what exactly it does or where it comes from. That's because it doesn't act like regular matter. We can't see it or feel it. We just know it's there because of how it seems to bend gravity. Even though regular matter and dark matter are very different, they seem to exist in a balance. Some scientists think this must be connected somehow. A new theory suggests that for every way regular matter moves, there's a mirror version of it in the world of dark matter, like a bridge connecting the two worlds. There's also a strange coincidence in regular matter where a neutron and a proton have almost the same weight. This allows them to stick together and make atoms stable, making everything that we can see with our eyes exist. If protons were a bit heavier, there would be no balance and atoms wouldn't form. In the dark mirror universe, maybe things happen differently. Maybe in there, the equivalent of a proton doesn't bind to other particles, leaving behind lonely neutrons, which could be the source of dark matter. This theory also suggests that dark matter might have its own chemistry, like dark atoms and a dark periodic table. For the longest time, scientists believed there was just one type of dark matter. Although these particles are similar in some ways, like being almost invisible, they may vary in their sizes, speeds, and how they affect regular matter. If this idea is right, it means there could have been interactions between our universe and the dark mirror universe in the past. Studying how elements formed in the early universe might give us clues about this. The idea of a flipped world has sparked curiosity and even some confusion in the scientific community in recent years. Astronomers use a theory called the Lambda CDM model to explain the composition and behavior of our universe. According to it, most of the universe is made of two things: dark energy and dark matter. Dark energy is like the pushing force that makes the universe expand faster. Dark matter is this invisible thread that pulls things together with its gravity, acting like a universal glue. Regular objects, like stars, planets, and comets, only make up a small part of the mix. The model also tells us about the Big Bang, and how everything started from a hot, crowded beginning, and how the universe has been growing and changing ever since. While this model seems to be correct in many ways, it doesn't explain all cosmic phenomena. If you were to draw this model on a piece of paper, it would look like a series of flat pancakes stacked on top of one another. Each one of the pancakes represents a rendition of the universe at a certain point in time. Yesterday's universe would stand below that of today, but it would be a slightly smaller pancake. By the end, you'll see that the universe's history looks like this giant upside-down cone, with its minuscule tip being the Big Bang. Beyond this point, we can't see any further away in time with the tools we have, so we don't know what's beyond. More so, we're still not even sure what happened immediately after the Big Bang. But if we simply apply the math, the universe might go beyond this historical tipping point, which could mean it could go in reverse, creating a similar mirrored cone where time would flow backwards, in our perspective at least. This alternative idea not only challenges our understanding of cosmic origins, but also raises questions about fundamental principles in physics. All the excitement around a mirrored universe also came from ANITA, a scientific instrument stationed in Antarctica, and its discoveries. This device saw some weird high-energy particles seemingly bursting from beneath the Antarctic ice. The problem with these particles is that they didn't behave as the laws of physics dictate. Scientists think they have a type of cosmic rays. They travel from space through the Earth and back out again. But the particles we already know about shouldn't behave like that. That's because higher energy particles usually collide with something inside the Earth and don't come out the other side like these do. They seem to be doing things both forward and backward. For now, there's no concrete proof of a mirrored universe. These particles could simply be ones we haven't discovered before, and scientists need to study them closely to come up with a definitive answer as to why they're behaving like this. Kind of like 4-year-olds. But what if there isn't just one other universe, but many more? This multiverse concept comes from ideas like the inflation theory, which says that our world had this rapid expansion in its early stages. While inflation stopped in our neighborhood billions of years ago, it's likely that it continues in other regions of the multiverse, creating different universes with their own laws of physics and unique characteristics. Our universe is the only one that we know of that can support life. We have stable stars that can provide heat and warmth, for example, which is crucial for creatures to start moving around. We also have an abundance of elements like carbon and hydrogen, which we also need to exist. The multiverse hypothesis gives an explanation for why our universe exhibits such life-friendly conditions. It may explain that there are countless other universes out there, with varying conditions, making the existence of life in at least one of them less likely. One fascinating implication of the multiverse theory is the idea of doppelgangers, these exact copies of individuals existing in parallel universes. This notion suggests that within the vast expanse of the multiverse, there could be infinite scenarios where identical versions of ourselves are experiencing similar events at the same time. Before we begin our travels to different universes altogether, we might need to understand our own. There's this galaxy, for instance, far from us, that might have no dark matter at all. It's about 250 million light-years away and looks normal at first glance. But if we look closer, we can't seem to find any dark matter. If it turns out that there are more galaxies like this one, it could change our ideas about how galaxies are made. Dark matter is usually thought to be necessary for this process, acting like the glue that holds the whole thing together. It is true, however, that this particular galaxy is more faint and has fewer stars than usual. When it was first discovered in 2019, scientists thought it might not have dark matter because of how fast it was spinning. The speed at which a galaxy spins tells us how much stuff there is in it. By comparing this speed with what we can see, astronomers can figure out how much extra stuff, like dark matter, must be there. And in this unique galaxy, the math says there isn't any. Among all these theories, there's also one that says dark matter might not be real at all. This new study proposes that maybe we've been looking for something that doesn't even exist. They think that our understanding of gravity might not be good enough to explain why some galaxies behave oddly. So instead of dark matter causing these weird behaviors, they say it might just be that we don't fully understand how regular matter works. They base these findings on a theory called modified Newtonian dynamics. It suggests that gravity behaves differently at very large distances or very low speeds. Strange explosions in vibrant blue colors are popping up around the universe and keeping astronomers intrigued. This rare and incredibly powerful event has a fancy name: Luminous Fast Blue Optical Transient. This phenomenon doesn't behave like anything else we know of, and things got even stranger when the most recent one happened in a spot it shouldn't have. To really understand what happened last year, we need to go back a bit. This type of strange explosion was spotted first in June 2018. The blue blast happened about 200 million light-years from Earth and got the nickname the Cow. No, this happening didn't resemble a cow at all, but it did have an unusual format. Back then, this blast was the most asymmetrical explosion ever seen by astronomers. It burst into space in a flattened pancake-like shape, not in a typical sphere as they would expect. This phenomenon was similar to a supernova, which is the most common type of cosmic explosion that happens when a star exhausts its nuclear fuel and collapses under its own gravity. However, scientists also noted three crucial differences. Number one, this phenomenon is more powerful than a typical supernova. When it happens, the blue burst emits more energy than an entire galaxy of hundreds of billions of stars like the Sun. Number two, it's much faster. The explosion reaches its peak brightness and fades away within a matter of days, while a supernova can take weeks or even months to completely dissipate. Then the last difference, these blue bursts can also be much brighter. These mysterious objects are considered the brightest known optical phenomenon in the universe. But unlike a regular supernova, it's believed that there are no radioactive elements to power this brightness. So that means the power must come from somewhere else. The question is, from where? This is just one of the mysteries that the scientists are trying to figure out. There have been some heavy investigations since the event was first observed, and 15 telescopes around the world are constantly looking for it. Since 2018, these extreme explosions have been spotted about once a year. So while they're rare, they're not incredibly uncommon. There are several possible explanations for the existence of these fast optical transients. Perhaps the most acceptable one is that it is a stellar corpse. I mean, what is left behind when a star calls it quits. So we're looking at two prime suspects here. They could be a neutron star or a black hole, producing emissions close to the speed of light. The theory goes like this. There is a massive star much larger than those that produce regular supernovas. Then it starts to collapse. Such an event would certainly be expected to leave a black hole behind. Let's say this massive star isn't ready to leave the universe in a quiet way. Instead, it creates a swirling disk around the black hole composed of gas, dust, and other matter, like it matters. This disk, called the accretion disk, can shoot out streams of material at incredibly high speeds, almost like powerful cosmic jets. And that could be exactly what we see as those sudden bursts of light. Again, it's just a theory. What exactly sets off these blasts remains a mystery, and much more observation and analysis are needed. Experts believe that explaining such an oddity is a scientific goldmine. After all, we're talking about a stellar corpse that isn't just sitting there, it's actually quite active. Now, since this event was first spotted, all similar occurrences that our telescopes have captured happened in the same place. I mean, the explosions always occurred in the spiral arms of different galaxies. But last year, things changed. The Hubble Space Telescope left scientists speechless in April 2023 when its images caught this same type of weird explosion happening for the first time in the middle of nowhere. Well, it didn't happen inside a galaxy as it was supposed to. It happened in the space between two of them. More precisely, about 50,000 light-years from a large spiral galaxy and about 15,000 light-years from a small one. This event is known today as the Finch. Oh great. So when we finally get closer to finding some answers, the unusual location of the Finch phenomenon came to mess it up again. So maybe there is another explanation for it. Speculation began soon after the discovery. One idea is that it could have been a collision between two neutron stars traveling far outside their host galaxies. These two could have been spiraling toward each other for billions of years, and when they collided, they produced a flare over 100 times brighter than a normal supernova. For this hypothesis to be correct, one of these neutron stars would have to be highly magnetized, amplifying the explosion. Another possibility is that the explosion was a star being torn apart by a black hole with a mass between 100 and 1,000 times that of the Sun. Although we still have lots of questions, one thing is for sure. The Finch is a luminous, fast black optical transient. Except for the weird location where it happened, it has all the other characteristics to be classified as one. It's super bright, like me, and super fast, and its origin is super hard to explain. Plus, the data from the Gemini South Telescope, the Chandra X-ray Telescope, and the Very Large Array Radio Telescope have confirmed it. Adding this latest information only makes it harder and harder for researchers to finally find some kind of pattern in this whole event. The Finch isn't the only peculiar event in this category. Let's head back to the year before, to 2022. A blue explosion was spotted in September, and it got the nickname of Tasmanian Devil. Just like the previous ones, this blue burst came up and disappeared very quickly. Then, something mysterious happened. Exactly 100 days later, observers who were still tracking the phenomenon got an early Christmas gift. They observed another flare-up, and it was as bright and fascinating as the original one. Wait, so we're talking about two similar and strange explosions that happened at the same spot and close in time? Well, this was a first. Quickly, 13 telescopes around the globe all had eyes turned toward the Tasmanian Devil event, including one equipped with a high-speed camera. Over the course of 120 days, they managed to capture another 14 irregular light pulses. This was certainly amazing because it proved that instead of showing up once and fading away as expected, the Tasmanian Devil continued to explode with supernova-like energies again and again and again. Can you imagine such power? This scenario still intrigues the scientific community because it pushes the limits of physics, not only because such extreme energy production, but also because of the short duration bursts. By the way, its flares last from 10 minutes to about 4 hours. Believe me, on the scale of the universe, that's considered super quick. This was the only time that an extended season of this event was observed. However, after some thought, the scientific community split their opinions about it. On one hand, the Tasmanian Devil could have been an utterly unique and one-of-a-kind event. On the other hand, maybe it was just the first time that our telescopes caught it from a more face-on angle. To further understand what's happening, scientists still need to observe larger samples of the phenomenon. All hopes are in the upcoming Vera C. Rubin Observatory, which is currently being constructed in Chile. It will have a 27.5-foot wide telescope, coupled with the world's largest digital camera ever fabricated for this purpose. According to NASA, this technology might finally give us some answers about these blue explosions. We can expect some exciting times ahead, as this could be the start of a new chapter in our understanding of stellar evolution.
Well, your childhood dream is coming true. You've been selected as one of the volunteers to go to space as a tourist. It's time to pack your bags. Must check the airline? Strike that out. Make it spaceship luggage restrictions. And trust me, the low-coaster airline rules down on Earth are nothing compared to the do's and don'ts for the International Space Station. A regular mission to the ISS lasts 6 months, so any ship going up there brings supplies for the astronauts already there. And it's not just some vital materials to keep the mission running, but also crew care packages. Those are meant to make life among the stars more comfortable and include something nice from the crew members' homes or the support staff. There's a weight limit of around 11 pounds, and the size of the package is 9 by 16 inches. Food can be inside, but anything that can produce crumbs isn't welcome. Perfumes, aftershaves, mouthwash, and anything in pressurized cans like shaving cream aren't allowed. And in case you were wondering, video games can't be in your crew care package. There could be some problems with batteries up there. So no video games for months? I might reconsider my astronaut career. Clothes are good to go, but only if they're 100% cotton. One more thing that takes off with the spaceship is an official flight kit. It has around 120 pounds of flags, patches, stickers, and other merch. And no, it's not for sale in case we do find life on Mars. These items from NASA, commercial partners, and international organizations are supposed to come back to Earth to be used as souvenirs, museum exhibits, or awards. And, of course, you'd have to send NASA an official request, and they'll decide which items and how many can go. Now, life in space would be sad if you can't bring something that reminds you of home, right? Well, NASA's got you covered. You can also bring a personal preference kit on your mission. Don't get too excited though, it's just around the size of a lunchbox and can fit a bit over 3 pounds. PPK was introduced during the Gemini program, when 2 people could fit into a capsule instead of 1 like before. Back then, personal items had to go inside a gray nylon bag with a drawstring. Astronaut Wally Schirra chose to pack his bag with 20 gold medals, 5 silver medals, flags, patches, and a Florida hunting license. I wonder what plans he had for his time in space. His colleague, Michael Collins, who went on the first mission to the moon, brought 3 flags with him, among other things. Years later, he took part in a NASA poll on Twitter and shared that he wished he had brought coffee and a good book to read. The more popular choices for PPK are family photos, ball caps, t-shirts, pins, and other things with logos of universities or teams and other memorabilia that means something to them but remain a secret. Many crew members also bring musical instruments that later stay on the space station. One astronaut even got an alto saxophone for his birthday in space. That one must have been tough to hide. Another popular carry-on choice is camera gear. The views up there are too good not to capture. So, you finally choose the particular photos of your relatives to take with you and which should stay on Earth. You reach the ISS, embrace its residents, and naturally, your next wish is to take a shower after the trip.
But don't get your hopes up. Water doesn't flow in zero gravity, so you won't be able to take a refreshing shower up there. Plus, water is pretty heavy, and it would be pretty expensive to send rockets filled with it into space. So, astronauts use pre-moistened wipes or towels with liquid soap to wipe their hands and faces. Another wet towel can serve to clean the rest of the body. But what about hair? Well, meet your new friend, the rinseless shampoo. You can't let splashes of water escape and mess up the electronics, so you gotta use a straw-like nozzle to run the water through special bags made of foil and plastic. Most of the water used for it goes back into the air conditioning system. It gets filtered and recycled to be used for drinking. Now, astronauts do brush their teeth, but even that simple task requires some skill in space. You'll need to attach the toothpaste tube to a wall and then squeeze a tiny bead of water over the toothbrush. Then you can brush your teeth like you do on Earth, squeeze some more water, and wipe it off with a towel to clean the brush. And oh, there's no sink to spit into, so you'll have to take a couple of sips from your water bag and swallow the toothpaste with it. Boy, sign me up. All that space routine has worn you out. Time to replenish your energy supplies. Luckily, space food is no longer mashed up in a tasteless mix and packed in tubes we've all seen in movies. Space food advanced along with space technologies, and now astronauts have a diet similar to yours down on Earth. They can eat fruits and brownies in their usual form. When someone on the ISS wants to snack on mac and cheese, they just need to add some water to it. There are no fridges up there, so you can't bring your favorite ice cream, and all other foods must be properly stored. It mostly comes in plastic packaging or cans. To prevent your meal from flying away, that packaging comes with Velcro patches and can be attached to a tray or table. There's a convection oven, so those lunches among the stars won't be as cold as outer space. Astronauts get 3 meals a day, and nutritionists make sure they're all well balanced. You can choose between coffee, tea, orange juice, fruit punches, and lemonade when you feel thirsty. Fizzy drinks don't fizz in freefall, so you can't bring soda. There's ketchup, mustard, and mayo to spice up your diet, but the salt and pepper only come in liquid shape. Otherwise, they clog the air vents and other equipment or get stuck in the astronauts' eyes, mouths, and nose. Yep, we already know crumbs aren't welcome in space for the same reason. But what about bread? One option is to replace it with tortillas. Another option is to sneak a sandwich on your spaceship without anyone knowing. John Young tried it once, but the crumbs were a disaster, so he couldn't enjoy his corned beef sandwich at all. You could also wait for the scientists to find a solution. They've been working on it for a while. A German company called Bake in Space teamed up with the German Aerospace Center and a bunch of researchers to create the perfect dough and find a way to bake it right in space. They need a special oven, and its surface shouldn't heat up over a certain temperature. So far, the astronauts have successfully baked cookies on the ISS. It took way longer than it would in a regular kitchen, but the result was worth the wait. The whole station smelled like cookies. Speaking of smells, they can hang on for years in the space station, and you just can't open the window and air the room, you know. So even a non-toxic material can give off odors that could tamper with the astronauts' work or even make them sick and put the mission at risk. That's why NASA has its own chief sniffer, also known as Nostradamus. His work is to smell all objects that will be in the habitable zone of the ISS. Now, you can't wait to journal about everything you've learned. Too bad pencils aren't welcome in space. The lead could easily break off, float away, and cause some major drama. A regular pen wouldn't work in weightlessness, so a special pressurized space pen premiered back in 1968. There are around 80 models of it now, and dozens of them are currently floating on the ISS. It's been one busy day in space so far, and your mission is just getting started.
Picture yourself floating in the endless expanse of space. There are no edges or corners, no up or down, left or right. It's like being lost in a galactic wilderness, except you can't rely on any natural reference points, or even on your usual sense of direction to guide you. And without gravity, you can find yourself tumbling and spinning in all directions, like being caught in a celestial tumble dryer. So what do you do? How do you know which way to go and how not to get lost? Well, this isn't a simple question. First, let's take a trip back to good old planet Earth, where direction is something we often take for granted. Imagine you're hiking through a dense forest. You're surrounded by towering trees, mossy rocks, and chirping birds. But there are no clear paths or road signs to guide you. So what should you do? The first thing that comes to mind is a compass, right? A small magical device that always knows where the north is, no matter where you are on the planet. All thanks to a tiny magnet inside. It feels the pull of Earth's magnetic field, which covers our planet like a cozy blanket. And this field is pulling the arrow towards the planet's north pole. Now, when you know where the north is, you can determine east, west, and south. At this point, you can navigate through the wilderness like a seasoned explorer. This is what we call a reference point. And it's not just about finding your way through the forest. Think about how you use reference points in your daily life. Giving and following directions on a map, using a GPS navigation system, or even just telling someone which way to turn at the street corner. Even in the skies we have them, using the water. Let's say you're embarking on a thrilling hot air balloon adventure. As soon as you rise into the sky, you're greeted by breathtaking views of rolling landscapes and glittering oceans. But how do you know how high you are? That's where sea level comes into play. You've probably heard phrases like above sea level or below sea level in your daily life. It's the average level of the world's oceans, a universal reference that acts as the starting point for measuring heights and depths. As you ascend in your hot air balloon, you can use instruments like altimeters to measure your altitude relative to sea level. It's like a ruler that tells you how far you've climbed into the sky. And it's not just for hot air balloon adventures. Altitude relative to sea level is used in various ways, from aviation to meteorology and to geography. It helps us understand and describe the height of mountains and the depths of oceans, the elevation of cities, and even the flight paths of airplanes. We're used to having points of reference on Earth, but when we go higher, things are getting much more complicated. In space, there are no natural landmarks, no compasses, and no universal altimeters. Without any fixed points of reference, determining direction becomes a real challenge. Even the stars, which are often used for navigation on Earth, can be misleading in space. On Earth, stars appear to move in a fixed pattern due to the rotation of our planet. But in space, they seem to shift and change position as you travel. So, what do we do? Well, we need some advanced technology and precise calculations. Our Intrepid spacecraft have clever ways to navigate the galaxy's seas. One of the most amazing tools spacecraft use for navigation is star trackers. It's like a cosmic GPS. They're the cameras that scan the night sky, capturing images of stars and using them as reference points. Just like we use street signs to find our way in a new city, spacecraft use the position of stars to determine their orientation and direction in space. Spacecraft can also use other celestial objects as navigation aids. For example, they might use planets, moons, or even asteroids to determine their position and direction. They create their own course based on these celestial bodies. For example, a course to fly from Mercury to Mars through Venus. It's like playing cosmic connect the dots with planets and moons. But it's not just about finding their way. Spacecraft also use these navigation methods to make precise maneuvers, like entering orbit around a planet or landing on a moon. They use complex calculations and precise measurements to determine their altitude, speed, and trajectory, using the positions of celestial objects as a compass. It's like a dance, where the spacecraft follows the cues to execute intricate maneuvers in the vastness of space. Another clever gadget is the gyroscope. It's like a space compass. Gyroscopes are incredibly sensitive and can detect even the slightest changes in orientation. They help spacecraft to stay stable, keeping them on the right track. Spacecraft also use cameras and lasers to capture images and measure distances to nearby objects, such as planets, moons, or asteroids. And don't forget about all the fancy software and algorithms. Inside each spacecraft, there's a genius computer brain that solves complex equations and makes decisions where to fly next. But that's us talking about directions. Now, what about the altitude? In space, altitude takes on a whole new meaning. It's like trying to measure the height of a skyscraper with no ground floor. So this cosmic conundrum requires some out-of-this-world creativity. Usually it's measured relative to the position of a spacecraft or satellite. If you're floating near a moon or some other celestial body and you want to know how high or low you are, you could measure your distance from this body's surface. For example, astronauts on the International Space Station might refer to their altitude as the distance above the Earth's surface, even though they're far within our atmosphere. And if the celestial body doesn't have a solid surface, like Jupiter, which is basically a huge ball of gas, oh well, then we just have to pray. Another method is to measure altitude relative to the spacecraft's orbit. You could measure your distance from your orbit center or plane and use that as a reference point. These methods might sound complex, but they're the easiest way to navigate and operate in space. They allow spacecraft to precisely control their altitude, speed, and trajectory. With these methods, they can even perform maneuvers like docking, landing, or rendezvousing. Space agencies and missions also act like interstellar traffic controllers. They have to ensure that spacecraft from different nations and organizations don't crash into each other. To keep things organized, they use standardized systems and conventions, just like how we use road signs and traffic rules on Earth. In addition to standardized systems, space agencies and missions also use conventions for specifying direction and orientation in space. For example, the right-hand rule. It's like a secret handshake for understanding the direction of things in physics and engineering. Imagine you have a magical glove that can tell you which way things will go in certain situations. Let's say this glove is on your right hand. Now, stick out your thumb just like you're giving a thumbs up. Your thumb represents the direction of the force or the push or pull of something. Next, curl your fingers around your thumb as if you're making a fist. Your fingers now represent the direction of a magnetic field or the rotation of something. Awesome! And now for the grand finale. Point your index finger straight out, like you're pretending to shoot a laser beam. Your index finger now represents the direction of motion or current flow. And there you have it. The right-hand rule is all about using your magical glove to connect the direction of force, thumb, magnetic field or rotation, fingers, and motion or current flow, index finger. It's a fun and handy trick that helps to solve complex problems in physics and engineering, including navigation. Space exploration is an adventure that challenges our perception of direction and orientation, making us realize just how much we rely on our home planet. Who knows what other crazy ways await us in the future? For example, quantum navigation, or when we'll create warp speeds like in Star Trek. Methods that would be not only practical, but also awe-inspiring. Let's wait and see.
These eerie objects are called quasars. They're some of the brightest and most powerful objects in the universe. They lurk in the depths of space, consuming entire galaxies with their insatiable hunger. But what are quasars? Where did they come from? And most importantly, are they dangerous to us? Picture a supermassive black hole, a cosmic monster so massive that it can swallow entire stars and bend the fabric of time. Usually, there's such a black hole in the center of every galaxy. That includes our own Milky Way galaxy. Ours is named Sagittarius A star. Sounds like the name of a hipster coffee shop, but in reality, it's a terrifying celestial body which is 4 million times heavier than our Sun. You could even see it online. For the first time, we took a photo of this black hole in May 2022. But don't worry. Even though it's supermassive, it's not going to swallow us up anytime soon. This black hole is relatively small and is too tiny to eat an entire galaxy. So it's more like a cosmic vacuum cleaner that sucks up stars or gas that gets too close. But there are black holes in the centers of galaxies that are way heavier and more dangerous than ours. They can weigh millions or even billions of times more than our own sun. Now, imagine one of these monsters. Usually they're surrounded by a swirling, glowing disk of gas and dust, like water swirling down a drain. It's called an accretion disk, and it's where the magic of quasars happens. As material from the accretion disk falls toward the center, it heats up to millions of degrees, releasing vast amounts of energy in the form of radiation. And this radiation is what we observe as a quasar. So basically, the more material a black hole can consume from its surroundings, the brighter its quasar will be. This is what makes them so bright and powerful, shining like beacons in the night sky. And just imagine, some black holes can actually make entire galaxies their meal. Now, combine their ravenous appetite with some intense radiation, and you'll get a truly awe-inspiring display of cosmic power. No wonder we can see them, even though they're some of the most distant objects in the universe. Quasars were discovered in the late 1950s by accident. Astronomers were just chilling and looking at the sky when suddenly they stumbled upon something strange. Radio signals that had no visible source. By 1960, hundreds of these strange objects had been found. Astronomers named them quasars, short for quasi-stellar radio source. These objects were small and far away, but their energy output was immense and difficult to explain. Some thought that these were new types of stars. Others even proposed wild things, like quasars being made of antimatter or being the end of a wormhole. But all these theories were discarded. A scientist named Martin Schmidt was the first one to get to the truth. However, many astronomers didn't believe him. Schmidt had to do a lot of extra work and gather lots of evidence to prove his theory. And finally, he prevailed. And that's how we discovered quasars. Don't you love the scientific method? And since then, astronomers have been captivated by these objects. Why? Because they have some pretty eerie qualities. Hey, you could call them quasi-quasars. For example, they kind of defy the laws of physics. They emit jets of particles that travel at speeds close to the speed of light. These particles move so fast that they can even distort the very fabric of space and time. But sometimes, they also help us confirm the laws of physics. Now imagine driving a car. As you drive, objects in the rear window start to appear smaller and smaller until they disappear from view entirely. That's exactly what happens with quasars, except they're moving away from us at incredibly fast speeds, up to 90% the speed of light. Wonder why they're trying so hard to sprint away from us. But in any case, this helps us confirm that the universe does expand for real. Another eerie thing about quasars is that they're incredibly old. Some even date back to the time when galaxies were forming, or to the birth of our universe. Additionally, quasars are some of the most distant objects that we can observe in the universe. Some of them are located billions of light years away from us. This means that when we observe a quasar, we're actually seeing light that was emitted billions of years ago, when the Earth was much younger and different than it is today. And that's why they work like cosmic time capsules. Studying them gives us a glimpse into the distant past. You see, galaxies are like giant cities, with stars and planets serving as the inhabitants. But just like cities evolve over time, galaxies also undergo changes as they age. And that's where quasars come in. They're like the urban planners of the universe. They shape the galaxies through their powerful gravitational influence. By eating galaxies and releasing intense radiation, they can trigger star formation and shape the structure of the galaxy itself. It's like the cosmic equivalent of a master chef, or a leaf blower, you pick. For example, let's take galaxy mergers. Here are two massive entities coming together, swirling and spinning around each other. As they get closer and closer, their gravitational pull becomes stronger, and they start to merge into a new, bigger galaxy. It's a beautiful and dramatic process, one that can take millions of years to complete. But all this doesn't go without consequences. The gas and dust within the galaxies collide, creating massive shockwaves that trigger the birth of new stars and even supermassive black holes. And this is where the quasars come into play. Some quasars may be born during these galactic get-togethers, and thanks to this, They help us study the effects of this process and the evolution of galaxies over time. But it's not all serious science and no fun. For example, how about gravitational lensing? Now, that's something straight out of a sci-fi movie. It happens when the gravity of a massive object, like a quasar, bends the path of light from a more distant object, like a galaxy, behind it. It's like having a really big magnifying glass in space. When you combine a quasar with gravitational lensing, you get some seriously awesome cosmic eye candy. The result is kind of like a funhouse mirror, where objects appear warped and twisted in strange and mesmerizing ways. Gravitational lensing isn't just for show. It's also a powerful tool for astronomers to study the distribution of dark matter and the structure of the universe. And that's not all. Some scientists have proposed that quasars could help us build the map of the universe. They can work like giant neon road signs. Turn left at the quasar and you'll reach your destination. They're like lighthouses that help us navigate through space. By analyzing the light from different quasars, astronomers can determine the distances between them and create a 3D map of the universe. And the best part? Quasars are located throughout the entire universe. That's why this cosmic map can give us a comprehensive view of the universe on a scale that was previously unimaginable. Who knew that a giant galaxy eater could be so useful? There's still a lot we don't know about these mysterious objects. In 2007, a team of astronomers made an astonishing discovery: the first true binary quasar. Basically, this means two huge quasars spiraling around each other. What's more, they were hiding in plain sight. For years, scientists had known about this radio source, but had never realized that it actually comes from one lovely couple. The astronomers also estimated that this pair may have a mass of about 100 billion suns. They're super distant, though, at an astounding 12 billion light-years away from our blue planet. Overall, quasars are a fascinating and complex phenomenon that continues to baffle and intrigue scientists. They may be cosmic galaxy eaters, but they're also playing a critical role in the formation and evolution of the universe. And who knows, maybe one day they'll become one of the keys to unlocking the mysteries of our universe. Oh, you crazy quasars. So, dark matter is a mysterious substance that makes up about 85% of the total matter in the universe, yet we can't see it or touch it. The regular matter that we're used to forms stars, planets, and everything around us. But dark matter doesn't emit, absorb, or reflect light, which is why we can't even see it. We don't even know if it actually exists. The reason why we believe in dark matter is because it leaves gravitational effects on galaxies and other cosmic objects. For example, spiral galaxies spin in a way that doesn't match the law of physics we know. According to our current knowledge, the outer edges of these galaxies should slow down, but they don't. They either keep the same speed or even speed up. It also seems to be acting like an invisible glue that holds galaxies together. If dark matter didn't add some invisible gravitational mass, the galaxies would literally break apart, not being able to hold stars together. But even though it's fundamentally important for our world, we still don't know exactly what dark matter is made of. This has been going on for years. Some experiments saw hints of it, but no one's been able to prove it beyond a doubt. Maybe the future Circular Collider will be able to find it. There's a mysterious force in space that seems to be pulling our entire galaxy, along with many others, toward it. This force is known as the Great Attractor, wink wink. It's a crazy massive region in space, about 10 million billion times the mass of our Sun, with a super powerful gravitational pull. Scientists think it might be a super cluster of galaxies, but they're not sure. The problem is, we can't see it directly because it's hidden behind the Milky Way, while the Milky Way itself, horrifyingly, is moving toward it at a speed of about 370 miles per hour. Now, just like with dark matter, we only know it's there because of how it affects the movement of galaxies around it. These galaxies are being pulled toward this region, even though, since the universe is expanding, they should be moving away from each other. What's even weirder is that this great attractor might itself be moving towards something even bigger, the Shapley supercluster. It's the largest concentration of galaxies in our nearby universe. In 2017, astronomers discovered a strange object called Oumuamua. This was the first known visitor from another star system. The thing was quite small, from about 330 feet to about 0.6 miles long. It was also long and thin, had a reddish color, and moved in a very unusual way. As it passed by the Sun, it unexpectedly sped up and then left our solar system just like that. Tons of theories started sparking up. It was too weird looking for an asteroid. Scientists thought it might be a comet, but it didn't have the usual traits of one, like a tail of gas and dust. Eventually, some scientists even started to suggest the wildest theories, like it might be an extraterrestrial probe. People have been making a huge fuss about Oumuamua ever since. But after a while, it turned out it was just a natural object with unique properties. It was probably a fragment from a distant star system, like a piece of a disintegrated comet or even a chunk of a planet. But Oumuamua caught everyone's attention so much that in 2022, astronomers even proposed to send a spacecraft to catch up with it. This mission could take about 26 years. Hey, stay tuned. Now, as for extraterrestrial creatures, where is everyone? There's this thing called the rare Earth hypothesis that suggests that life as we know it is actually super rare in space. In the 70s and 80s, scientists argued that Earth is just an ordinary planet in an ordinary solar system. If we look at it this way, life should be widespread across the universe. It seems unreasonable to think that with trillions of planets out there will be no planet like ours anywhere. But then, a geologist, Peter Ward, argued that the development of complex life like ours depends on a very rare combination of things. The history of the planet, with all of its astrophysical and geological conditions, should line up perfectly for complex life to develop. So, just think about it. Being in the right zone of the galaxy, on a good distance around a stable star, a rocky planet with water and the right temperature, emergence of molecules, monkeys deciding to walk, and so on. This would explain the Fermi paradox, which asks, if extraterrestrial life is common, why haven't we seen any signs of it? Well, the rare Earth hypothesis explains it. The universe might be full of plants, extraterrestrial critters, and fun animals. But would there be an intelligent species like humans? That's another story. As for humans being intelligent, that's another matter. Dark matter? And even if they do exist, we could be incredibly far away from each other. That would make communication or contact with other intelligent species very unlikely. Now, there's another similar theory called the Great Filter. This idea says that there might be a big obstacle somewhere along the path from microbes to advanced civilizations. It was the idea of the economist Robin Hanson. He also believed that maybe intelligent life, as we know it, isn't that common in the universe, although he assumed it's not because our planet was the result of tons of unique conditions, but because there must be some sort of filter that reduces the chance of life progressing to our point. Who knows where this filter is? It might be in the stage of early microbes, which means that we managed to get through it or somehow ahead in the future, which means we might go extinct like many other species before us. Well, maybe in the next stages, such as colonizing other planets and the galaxy, are much harder, if not impossible. Something unexpected might come up, potential catastrophes, resource exhaustion, or other challenges. Now, there's this thing called a pulsar. It's a weird type of star that sends out regular bursts of radio waves, like a flickering space lighthouse. You see, in space you often find a pulsar and a smaller companion star that rotates around it. But one day, scientists discovered this system, which was also surrounded by tons of some energetic material. They suddenly realized that these are probably the remains of another companion star, which was very big in size. But the pulsar was blasting out powerful radiation and particles, slowly consuming its companion. This is kind of like how a black widow spider eats its mate, hence the name. Since then, they've found other similar systems. They've grouped them all into one spider family. There are also redback pulsars, which destroy slightly larger companions, and Huntsman pulsars, which have companions that are massive enough to resist being completely destroyed. Even though so many safety measures are taken, space is still an unpredictable place where we don't have as much power as we'd like to. Back in 1973, during a spacewalk on the Skylab space station, 2 astronauts were in a very risky situation. They were out in space fixing things, but they didn't have the same handy jetpacks like astronauts do today. They could only rely on safety tethers. Suddenly, the solar arrays they were working on moved unexpectedly and pushed them out of their position, almost sending them drifting off into space. Thankfully, the safety ropes did their job. Strong, resistant to heat, and attached to astronauts' waists, these tethers can hold a weight of about 881 pounds. This accident happened before SAFER came into use. It's easy to understand why accidents at work are way scarier up there than some regular 9-to-5 job on Earth. But that's why you have more training and special equipment to keep you safe. First, astronauts are always attached to the spacecraft with tethers, so they don't float away like a helium balloon. It may seem like a spacewalk is such a big deal that the ISS needs to stop when the astronauts are out there doing their thing, but it's not like that. If the ISS were ever to stop, it would fall straight down to our planet. So, once an astronaut is in a stable orbit, they stay in that orbit, unless some new force acts out. The first spacewalk wasn't as simple as those done later. It was performed in 1965, and it lasted 12 minutes. 2 men set out on a mission. One of them was supposed to float in space for a while taking pictures. But things went wrong. His spacesuit expanded too much, making it hard to move. He started to feel overheated, so he had to let some oxygen out of his suit, which was very risky. He could run out of air or get sick like a deep-sea diver. Getting back into the spacecraft was tough as well, but he somehow managed to do it. Then, more problems came. The spacecraft started spinning, oxygen levels rose dangerously, and there was a risk of an explosion. After a lot of struggle, they made it back to Earth, but landed in a random forest surrounded by wolves and bears during a snowstorm. It took a rescue party to find them. Not a very encouraging story to listen to while you're waiting to go out. But cheer up, things have improved since then. Hundreds of astronauts have taken spacewalks without any serious problems. So here you are, whizzing right along with the giant ISS. Your first spacewalk goes almost flawlessly, so you can enjoy the view a bit. It's hard to control the way you move, but tethers still do their job, so you can focus on your task. Until you realize they failed. How did they untie? You notice you're floating off in some random direction. There's nothing you can hold on to. Your body is weightless, and it has started to spin around. It's so frustrating when you can't take control of your movements. An astronaut named Scott Kelly described this unpleasant feeling in his book Endurance. He was turning around and upside down in the darkness and could see nothing but what was right there in front of his face. It was like a scuba diver floating in murky waters, totally disoriented, with no way of telling which direction was wrong and which one could be right. In space, you can't kick or flail to change your course. It might be fun floating inside a spacecraft with zero gravity, playing and fooling around, but seeing just the endless void filled with stars in the distance and knowing what could happen makes it frightening. And now you're getting closer to Earth's atmosphere. It might seem like the safest option because it makes you feel like you're going home, but in reality, you better hope you'll change direction. If your angle and speed are wrong, you might re-enter the planet's atmosphere and burn up. Not a good deal. NASA trains astronauts for such situations, so you know what's your next step. Activating an emergency jetpack called SAFER. This tool is designed to help you stabilize and move in space. You don't even need the tethers. You can control the movements of your jetpack with a small joystick. Finally, all those hours of playing video games will pay off. These jetpacks became an inevitable part of the spacewalk package almost 30 years ago. So far, no astronaut has had to use one during a spacewalk. Whew! You're back on track, and you're moving away from Earth's atmosphere. You're getting closer to the ISS, flying manually. Oops! These jetpacks have one big flaw. they have a limited amount of fuel, and your safer has just run out of it. Okay, take a deep breath. One of the most important things every astronaut has to learn is to be prepared for literally anything. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that yes, and these signals aren't anything new. They'd been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating "match not found" message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. Over billions of years, the surface of the Moon has been hit by asteroids and comets, causing bits and pieces to constantly break off from the impacts. Because of this, all the surface material is pretty loosely packed. So when there are quakes, slopes in the same area can become susceptible to landslides or new faults opening up. Future settlements located too close to these unstable slopes could put everyone living inside these lunar bases at risk. Moon dust adds another layer of complexity because without erosion or water to smooth it out, it can harden to the point of being as tough as glass. If we really want to understand how dangerous moonquakes might be for people living and working on the Moon in the future, space agencies still need to map out and get new seismic data, and not just from the South Pole, but from the entire satellite. In 2025, the Farside Seismic Suite mission, or FSS, plans to deploy two of the most high-precision seismometers ever built to the Schrödinger crater, which is located on the dark side of the Moon. Finding out what's happening on the ground there is crucial for understanding the complex lunar structure and its internal dynamics. Scientists are still trying to figure out whether the lack of recorded seismic activity on the far side of the Moon is due to current instruments not being capable of detecting it, or if it's due to some kind of interference from melted material in the mantle. Once they have this answer, it will be easier to fully understand the phenomenon of shallow moonquakes and assess their implications for future neighborhoods on our natural satellite. Now, you may have heard that Earth is also shrinking, but it's a different process. Basically, the Moon is getting smaller mainly because its core is cooling down naturally. The Earth's core is cooling too, but our planet got its crust with tectonic plates, unlike the Moon, which only has one plate. So the energy from Earth's core shifts those plates around or comes through volcanic eruptions. Earth is actually losing mass overall due to atmospheric loss. Our planet loses about 100 million pounds of mass per year, mostly from a leaky atmosphere. Earth's gravity isn't strong enough to retain the lightest particles, like hydrogen and helium, which escape into space. But don't worry, these numbers aren't cause for alarm, considering that our planet's atmosphere weighs about 5 quadrillion tons, a number I can't even imagine. So, in other words, it would take many, many, many times the current age of the universe for it to completely evaporate. We found a water cloud in space around a black hole. It's a gigantic water reservoir that's located about 12 billion light-years away from Earth. This must be the largest and farthest water reservoir ever detected in the universe. This one cloud contains an astonishing 140 trillion times more water than all of Earth's oceans combined. That's wet. The water surrounds a quasar, which is basically an incredibly energetic supermassive black hole. This quasar is about 20 billion times larger than the Sun and emits as much energy as 1,000 trillion suns. You do the math. As the black hole slowly consumes everything around it, it releases energy. This energy heats the surrounding gases and dust, causing the formation of water vapor. As a result, the black hole is surrounded by a huge water cloud and all the other gases and dust bath around it. This pair formed when the universe was only 1.6 billion years old, just a fraction of its current age. That means that the water isn't young at all and has been existing in galaxies for billions of years now. This quasar will only keep getting scarier and bigger. If it eats up all this gas and dust around, it could grow up to 6 times its current size, potentially becoming 120 billion times larger than the Sun. Think about that. At first, it may seem like the Sun is burning, but it's actually not true, because the burning of our star isn't chemical combustion, it's nuclear fusion. The Sun can't run out of oxygen or stop burning because it doesn't use oxygen to burn. Regular carbon combustion requires oxygen. As soon as there's no oxygen, the process of burning stops. Now imagine a candle. If you cover it, it doesn't have access to oxygen anymore, and the process of burning stops. But in nuclear fusion, the nuclei of atoms are fused together to make new, bigger nuclei. Such changes cause atoms to become new elements. Nuclear fusion doesn't require oxygen or any other material altogether. You just need enough pressure or heat to squeeze the nuclei of atoms close enough for them to overcome their electrostatic repulsion and bond into one nucleus. In 2027, 2 teams of astronomers discovered a cloud of water floating in open space. It was the largest and farthest reservoir of water ever detected in the universe. It's a cloud of water vapor surrounding a huge black hole called a quasar, 12 billion light-years away from Earth. The environment around the quasar must be unique to somehow produce such giant masses of water. It was formed by energy waves colliding hydrogen and oxygen atoms together. The cloud contains 140 trillion times the entire volume of water on our planet. It could provide each person on our planet with a planet's worth of water 20,000 times over. Wow! Even cooler, astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself. Scientists consider it another demonstration that water exists throughout the universe and was present already during its early days. At the same time, before this discovery, scientists had never found water vapor present so far back in the early universe. There is water in our home Milky Way galaxy, but most of it is frozen in ice. Not only water is floating out there in space, alcohol too. In 2009, scientists were examining a massive cloud of gas and dust in the center of our galaxy when they stumbled upon a surprise. There was ethyl formate within the cloud. This chemical is responsible for the sweet flavor of raspberries. They also found one more cool region. This one was brimming with ethyl alcohol, the same type found in many beverages. At the North Pole of Saturn, a mysterious storm is raging. It's ginormous, spanning an area larger than our planet and showcasing a beautiful but baffling hexagonal pattern. No one has understood yet why the storm has such a bizarre shape. After the hexagon was first discovered in 1987, it remained hidden in darkness up to the moment when sunlight exposed it again. Soon afterward, the Cassini spacecraft, designed to explore the Saturn system, provided a series of captivating images and even a video of the hexagonal storm. It turned out to be colossal in size. Its estimated depth is around 180 miles, and the eye of the storm is 50 times as large as the typical storm on Earth. The storm is also changing its color from blue to gold. Winds of hydrogen and ammonia surround the storm and move at more than 300 miles per hour. The storm has several centers. Some of them move clockwise, and others follow a counterclockwise direction. The largest vortex appears to be white, and it's twice larger than the standard hurricane on our planet. As for the hexagon itself, it's a jet stream made up of atmospheric gases. Experts refer to it as just a current of air and weather features. But there is one intriguing detail: a vortex sitting at a higher altitude than Saturn's clouds. It looks like a large towering structure. Saturn's auroras, triggered by the planet's magnetic field, are located atop of the hexagon, giving its appearance a mystical vibe. Astronomers have found a giant, likely active volcano near Mars's equator. It was literally hiding in plain sight. It's ancient and deeply eroded, but seems to be still functioning. There may even be remnants of a glacier ice near its base. That's why this discovery might indicate a promising new location to search for life, as well as a potential destination for future human and robotic exploration. The structure is still awaiting its official name. At the moment, it's referred to as the Noctis volcano. It reaches a height of 29,600 feet and spans an impressive 280 miles across. Such a giant size indicates that the volcano has been active for a very long time. In its southeastern part, there's a thin, recent volcanic deposit, and beneath, glacier ice might still be present. At a distance of 700 million light-years away from Earth, there's a gaping hole, a blank void with no galaxies, stars, planets, or asteroids, literally nothing. The void is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there billions of times over. That's the mysterious Bootes void. It lies in the constellation of Bootes, the herdsman driving the plow around the North Pole. At first, this void had the name of the Great Nothing, but later it was given its current name. Now, we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters, but between these clusters and threads, there are enormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bootes void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. There is a diamond planet out there that orbits a star in the constellation of Cancer, completing one full rotation in a mere 18 Earth hours. The planet's scientific name is 55 Cancri e. The radius of this faraway world is twice as large as Earth's, and its mass is 8 times greater. The planet is scorching hot, the temperatures on the day side reaching almost 5,000 degrees Fahrenheit. But the coolest thing about 55 Cancri e is that, according to some specialists, at least a third of the planet's mass could be diamond. That's the equivalent of around 3 masses of our home planet. Sounds like big money floating out there in space. How about we calculate how much this planet could be worth? Wait, someone has already done it, and the number is astronomical, pun intended, of course. It's 26.9 nonillion, and if you're confused by this number as I am, that's 26.9 followed by 30 zeros. Now, for comparison, one of the most expensive diamonds on Earth ever is the Cullion. It costs a whopping $2 billion, and its original weight was a mind-boggling 3,106.75 carats. It was, and still is, the largest raw gem diamond ever found. Later, it was cut into many small diamonds. The largest of them is Cullion 1, which also goes by the name of Star of Africa. It has a carat weight of about 530, but imagine how much bigger and more expansive the Diamond Planet is. Nebulas are gigantic clouds of gas and dust, and some of them can have really unusual shapes, as if they were made this way on purpose. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. One day, this mass becomes so big that it collapses under its own gravity and forms new stars. Among some of the most beautiful nebulas out there, we must mention the Butterfly Nebula. Its wingspan is more than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 450,000 degrees Fahrenheit. It means it formed from a giant gargantuan star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. It's what probably makes the whole structure look like an hourglass or a butterfly. The Ring Nebula looks like a giant cloud of dust and gas surrounding an old, almost extinguished star. At first sight, it does look like a ring, but astronomers say the nebula isn't a bagel, it's a jelly-filled donut. They must be hungry. The deep space colorful object, more than 2,000 light-years away from Earth, is actually a ring that wraps around a blue ball-shaped structure. Each end of the structure sticks out of the ring's opposite sides. The pillars of creation look like something out of this world. See for yourself. They're located 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars just 5.5 million years old. On a space scale, they're just babies. Once, the Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. And now you can see them with your own eyes. Those are the so-called pillars of creation, an active star-forming region. Look at this famous image. The blue colors represent oxygen, red is sulfur, and green means the presence of both hydrogen and nitrogen. The pillars are also bathed in the ultraviolet light coming from a nearby cluster of young stars. Unfortunately, the winds from those stars are slowly but steadily eroding the magnificent towers of gas and dust. Far out in space, a ghostly, super-ancient galaxy is floating all alone. It shines with a faint glimmer of starlight and has hardly changed for billions of years. Astronomers have no idea why it's there or how it formed. Meet DG-SATI, a living fossil galaxy. It's as big as the Milky Way, but is nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone. Unlike other galaxies of this kind, which are usually found in clusters. It might mean that DGSATI was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia BH3. The proximity of this space object to Earth makes it the second closest to our planet black hole ever discovered. The nearest one is called Gaia BH1. Makes sense. It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of around 9.6 times that of the Sun. That means it's way smaller than the newly found black hole. Gaia BH3 is located in the Aquila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Now look at this marvelous exoplanet. It resembles a giant eyeball hanging out there in space. But it isn't the coolest thing about it. This distant world, identified in 2017, is one of the most promising places for finding life outside our solar system. The exoplanet is called LHS 1140b, and it shows signs of having a global ocean capped in ice. It's that very Iris, a huge region around 2,500 miles across, which is constantly gazing at its host star. The planet has a radius of about 1.73 times the radius of Earth, and is 5.6 times as massive as our home planet. The giant eyeball planet orbits much more closely to its star than Earth does. It needs just around 25 days to complete an entire orbit. If the star were similar to our Sun, such a distance would definitely be too close for life to appear on the planet. But instead, it's a cool and dim red dwarf. That's why the exoplanet lies in the habitable zone of its star, where it's not so cold that all surface water would freeze, and not so close that this water would steam away. At the moment, LHS 1140b looks like the most promising candidate for hosting life in our planetary neighborhood. Solar flares are extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. They occur when there's some magnetic disturbance in the Sun. Then, magnetic field lines in the atmosphere of our star get tangled and snap. This releases giant amounts of excess energy, including ultraviolet radiation and intense X-rays. These twisted lines appear in sunspots. Those are darker and cooler regions on the surface of the Sun. They form when magnetic fields that used to hide deep within our star rise up to the surface. As for coronal mass ejections, or CMEs, which are launched by solar flares, they're sent outward into space. They hit planets, satellites, and basically any objects in their path. Those that come across Earth trigger geomagnetic storms, which in most cases result not only in beautiful auroras, but also in power grid failures and satellite malfunctions. All these extreme solar phenomena, CMEs, sunspots, and solar flares, get much more intense during the peak of the Sun's 11-year-long activity cycle. It's known as solar maximum. Right before this event, the Sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emits powerful streams of radiation, and grows planet-sized spots. At first, experts were sure that the current solar cycle would reach its peak in 2025. But judging by recent numerous sunspots, intense solar storms, and some other rare solar phenomena, solar maximum is likely to arrive sooner than that. This planet is as light as a piece of fluff stuck to your jacket. In the scientific world, its name is WASP 193b, but we'll call it the Cotton Candy Planet. It's located around 1,200 light-years from us. We'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin. It has an extremely low density. Combined with other factors, like its high temperature and the infrared brightness of its host star, it makes it special. Interestingly, the planet's radius is just 1.46 times the radius of Jupiter, but its mass is a mere 0.139 times of our gas giant. May I have a close-up here, please? Thank you. See how fluffy it is? It would be absolutely impossible to stand on its surface should you ever reach this distant world. It's not often that you can meet something like WASP 193b at a planetary party. Such planets are rare. Their fluffiness might be caused by their planet stars. Those heat them, puffing them up like a marshmallow that's seen too much campfire action. The planet's super low density makes it a real anomaly among those 5,000 plus exoplanets we have already discovered. So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to high-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist. Now, in the 70s, we received a radio signal that lasted more than a minute, and to this day, no one knows what it was or where it was coming from. But now, a new theory has appeared. Could the mystery finally be solved? In 1977, at 11:16 p.m., a telescope in Ohio caught something very unusual in space. It was a super short radio signal, just 72 seconds long. The signal was so strong and weird that the scientist who found it wrote "Wow" in red ink next to it. That's why it's called the WOW signal. Now in space, hydrogen gas sometimes releases radio waves, a type of electromagnetic radiation. They emit at a specific frequency, which is like a unique signature for hydrogen gas. This helps us to find, identify, and study it. Thanks to this, we noticed that the WOW signal frequency came from the same place as this gas. But it's not like it helps much, because we still have no idea what emitted it. What's even stranger, the signal happened only once. Even though we tried really hard to hear it again, we never did. And without a repeat signal, it was impossible to tell what it was. It's hard for us to even get its precise location because the signal was short-lived. After a certain distance, it's very hard to tell where different radio signals are coming from. And that's where the theory started. This particular frequency that the WOW signal was on is special. It's not crowded with a lot of other signals. It's like finding a quiet spot in a noisy room. Because there's not much interference or noise, so if you send a signal on this frequency really far, it won't get lost or distorted. And that's curious, because it means that there might be a perfect place to send messages if we want to communicate with any extraterrestrial creatures out there. So, could it be that they're trying to contact us? Well, it's a real scientific possibility. No one knows for sure what caused the WOW signal. But if it was from something extraterrestrial, they definitely communicate not like we do. The signal looked nothing like a deliberate message, and that's weird that it happened only once. If it was little green people trying to contact us, it would be weird for them to only try once. But, just in case, in 2012, on the 35th anniversary of the WOW signal, we decided to send out a bunch of messages toward certain stars. We used a special code to make sure any extraterrestrial creatures who got the messages would know they were from intelligent beings like us. Well, mostly intelligent. We even used a lot of power to make sure the messages could travel really far. Scientists have come up with lots of ideas about where the WOW signal might have come from, but none of them are widely agreed upon. We know for sure that it didn't come from anything on Earth. Earth noise can interfere sometimes, but this signal definitely came from outer space. There was also a theory that the signal might have bounced off some space junk and come back to Earth. But later, we realized that the requirements for that to happen were very unlikely. One potential idea is that the signal might have been caused by twinkling in space, like how stars twinkle in the sky. But even if that's true, it doesn't rule out the possibility that the signal was made by something artificial. Another idea is that it could have come from something spinning, like a lighthouse. Or maybe it was a signal that changed its frequency over time. Or it was just a one-time burst. It's been 50 years since a strange radio signal was caught. But recently, a new idea about its origin sparked up. Now, imagine a comet streaking through space, leaving a trail of gas behind it, like a tail. This gas could be key to understanding the mysterious radio signal that caught astronomers' attention all those years ago. One of the astronomers looked at the WOW signal and thought it might be connected to a comet called 266P/Christensen. Yeah, that's a mouthful. This comet is about 1,800 light-years away. It wasn't known back in 1997 when the signal was first detected, but now it could explain the strange radio waves. Comets can emit radio waves as they get closer to the Sun. It's like the gases around them start buzzing with energy. This buzzing might be what the WOW signal was all about. To test this theory, we used a radio telescope to listen for radio waves from other comets. We found that some comets did indeed emit radio waves at the same frequency as the WOW signal. Then we pointed the telescopes at this particular comet as it passed through the same part of the sky where the WOW signal was detected. The comet's radio waves could match up with the signal, and while the comet wasn't exactly in the same spot as the signal, it was close enough to feel like we were onto something here. It also might have been caused by hydrogen clouds from two comets, the ones we mentioned, and another one called P/2008Y2. Who picks these names? But not everyone is convinced by that idea. Some say that the theory about two comets causing the signal doesn't add up, because comets don't usually emit radio waves in the ways needed to explain the WOW signal. Also, the signal didn't repeat itself, and only happened once, which is weird if it's really a comet. They spread out their gases over a large area, so the signal would have lingered longer. The telescope used to detect the signal should have picked it up twice in a short time span, but it didn't happen that way. Also, the comet wouldn't have moved out of the telescope's view so quickly. This shows that we need to learn more about how and why comets emit these radio waves, especially at the same frequency as the WOW signal. There are also a lot of mysterious and interesting signals in space. Most of them come from natural events, like something called fast radio bursts. These bursts of energy are incredibly powerful and occur all over the sky, but their origins are still unclear. They last for only a fraction of a second. Maybe the telescope caught just a part of one of these bursts. There's also a strange signal we've been receiving since 2018. This one actually repeats every 22 minutes, but despite our efforts, we can't figure out where it's coming from. It started way back in 1988, and we've been investigating this mystery for 36 years now. At least here we know the distance of the mysterious object sending the signals, a distant 15,000 light-years away. Some speculate that these signals could be from extraterrestrial beings trying to communicate with us. However, we can't say for sure without solid evidence, so it remains speculative. Another explanation is a pulsar theory. Now, pulsars are neutron stars that emit beams of energy, similar to what we've been observing with the signals. However, the behavior of the signals doesn't perfectly align with what we know about pulsars. There's also the magnetar theory, suggesting that these signals could be coming from supercharged neutron stars called magnetars. Yet, none of these theories fully explain the strange behavior of the signals. Maybe there's a new, undiscovered phenomenon in the universe. So even though comets are a possibility, there are still a lot of unanswered questions about the WOW signal. We don't know what caused it, and we may never know. We don't even know if it came from deep space or from somewhere inside the solar system. In any case, even if the WOW signal had a natural cause, it doesn't mean that extraterrestrial life doesn't exist. The study that talked about this also discussed a sun-like star that could be a great place to look for signs of technology from space. There are 14 more stars similar to our Sun in space, although we're not totally sure about their brightness. This opens up exciting possibilities for hunting down signs of advanced civilizations beyond Earth. Ooh. Just watching certain scenes from the movie Gravity was scary, let alone imagining what would happen if you really ended up in the cold, endless void called space without knowing if you'd be able to go back. But let's say you're really up there. You're so excited about your first spacewalk. It sounds risky, but it's something astronauts on the International Space Station do quite often. It's easy to understand why accidents at work are way scarier up there than some regular 9-to-5 job on Earth. But that's why you have more training and special equipment to keep you safe. First, astronauts are always attached to the spacecraft with tethers, so they don't float away like a helium balloon. It may seem like a spacewalk is such a big deal that the ISS needs to stop when the astronauts are out there doing their thing, but it's not like that. If the ISS were ever to stop, it would fall straight down to our planet. So, once an astronaut is in a stable orbit, they stay in that orbit, unless some new force acts out. The first spacewalk wasn't as simple as those done later. It was performed in 1965, and it lasted 12 minutes. 2 men set out on a mission. One of them was supposed to float in space for a while taking pictures. But things went wrong. His spacesuit expanded too much, making it hard to move. He started to feel overheated, so he had to let some oxygen out of his suit, which was very risky. He could run out of air or get sick like a deep-sea diver. Getting back into the spacecraft was tough as well, but he somehow managed to do it. Then, more problems came. The spacecraft started spinning, oxygen levels rose dangerously, and there was a risk of an explosion. After a lot of struggle, they made it back to Earth, but landed in a random forest surrounded by wolves and bears during a snowstorm. It took a rescue party to find them. Not a very encouraging story to listen to while you're waiting to go out. But cheer up, things have improved since then. Hundreds of astronauts have taken spacewalks without any serious problems. So here you are, whizzing right along with the giant ISS. Your first spacewalk goes almost flawlessly, so you can enjoy the view a bit. It's hard to control the way you move, but tethers still do their job, so you can focus on your task. Until you realize they've failed. How did they untie? You notice you're floating off in some random direction. There's nothing you can hold on to. Your body is weightless, and it has started to spin around. It's so frustrating when you can't take control of your movements. An astronaut named Scott Kelly described this unpleasant feeling in his book Endurance. He was turning around and upside down in the darkness and could see nothing but what was right there in front of his face. It was like a scuba diver floating in murky waters, totally disoriented, with no way of telling which direction was wrong and which one could be right. In space, you can't kick or flail to change your course. It might be fun floating inside a spacecraft with zero gravity, playing and fooling around, but seeing just the endless void filled with stars in the distance and knowing what could happen makes it frightening. And now you're getting closer to Earth's atmosphere. It might seem like the safest option because it makes you feel like you're going home, but in reality, you better hope you'll change direction. If your angle and speed are wrong, you might re-enter the planet's atmosphere and burn up. Not a good deal. NASA trains astronauts for such situations, so you know what's your next step: activating an emergency jetpack called SAFER. This tool is designed to help you stabilize and move in space. You don't even need the tethers. You can control the movements of your jetpack with a small joystick. Finally, all those hours of playing video games will pay off. These jetpacks became an inevitable part of the spacewalk package almost 30 years ago. So far, no astronaut has had to use one during a spacewalk. Whew! You're back on track, and you're moving away from Earth's atmosphere. You're getting closer to the ISS, flying manually. Oops! These jetpacks have one big flaw. They have a limited amount of fuel, and your SAFER has just run out of it. Okay, take a deep breath. One of the most important things every astronaut has to learn is to be prepared for literally anything. That's why they go through pretty intense training sessions, so they can remain calm even in very stressful situations. A long time ago, NASA would choose astronauts from test pilots who went through harsh training in the jungles of the Philippines without any help, so no instructions or supplies. Later, they implemented a special training regime with outdoor exercises in different climate environments and even underwater to simulate conditions in space. Today, astronauts are trained to work in teams to stay focused and calm while handling difficult tasks. For instance, when they needed to fix the Hubble telescope, astronauts had to work for more than 8 hours in the harsh conditions of space to remove a broken part. It was a frustrating task. Plus, the gloves they had to wear made things harder, but they still did it. They also train in a giant water pool in Houston, which is a pretty good replica for the ISS. That's where they practice spacewalks and try to repair things while being underwater all the time. The water makes them feel weightless, while their suits are heavy enough to mimic the effects they could experience during spacewalks. You also need to have sessions with aerospace psychologists. They help astronauts handle stress and stay mentally strong. They check astronauts before, during, and after missions, helping pick the best candidates for spacewalks. Not everyone can go through these harsh conditions. Out of 16, only 10 get chosen. Even though so many safety measures are taken, space is still an unpredictable place where we don't have as much power as we'd like to. Back in 1973, during a spacewalk on the Skylab space station, 2 astronauts were in a very risky situation. They were out in space fixing things, but they didn't have the same handy jetpacks like astronauts do today. They could only rely on safety tethers. Suddenly, the solar arrays they were working on moved unexpectedly and pushed them out of their position, almost sending them drifting off into space. Thankfully, the safety ropes did their job. Strong, resistant to heat, and attached to astronauts' waists, these tethers can hold a weight of about 881 pounds. This accident happened before SAFER came into use. When up in space, a lot of things can go wrong, and sometimes even astronauts' training and equipment can't help solve the problem. That's where the Mission Control Center on Earth jumps in. Thousands of people work on Earth to support the astronauts on the ISS. But if the communication system doesn't work, or no one's close enough to help, that's where the rescue operation stops. You just continue to move in a random direction, waiting for the 7.5 hours of air you have to run out. Feeling hungry? Unfortunately, you can get nothing but some water you have in your helmet. Maybe you'd stop spinning at some point. The view would be fascinating. You could watch the Earth rise and set about 5 times, depending on where you are. And while you'd be getting farther away, and Earth would be turning into a small dot lost among asteroids, stars, and space debris, a random picture would come to your mind. A stunning sunset at the beach, the sound of waves, and your favorite pizza. Now, it's so far, it almost seems like part of another dimension. We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes, and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that, yes, and these signals aren't anything new. They've been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely, it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space, much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny, superdense core is called a neutron star. Some of these neutron stars are extra special. We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, it gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with a magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds. A bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our Sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, And by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them. Now, get this. Octopuses are visitors from outer space. Here's how this would have happened. Ice-kept eggs of octopuses stuck in spatial bodies crashed into Earth. Then these guys would have mixed together with a pre-existing set of genetic information available on our planet. And presto, octopuses were born. Well, it may be a long stretch to justify that the highly intelligent octopuses are extraterrestrial beings. But the idea is based on a theory that has been around since ancient Greece, something known as panspermia. Now, panspermia is a hypothesis that says life exists all around the universe, not only in planets. So, things such as space dust, asteroids, and even spacecraft have their share of life glued to them. And when they travel across the galaxy, life is disseminated. This strand of thought has been polemic, since it goes against the idea that all life originated right here on our planet. But as much as this new octopus theory might be refreshing, it doesn't contribute too substantially to the search for life on other planets. It's just too hypothetical. Now, octopuses are in fact incredibly old. The oldest known fossil belongs to an animal that lived almost 300 million years ago. FYI, this is before our dinosaur buddies roamed the Earth. Wait, there's more! Octopus arms have a mind of their own. That's because 2/3 of their neurons lie in their arms, not in their heads. This means that their arms can problem-solve how to open a shellfish, while their owner is worried about other stuff entirely. Talk about ninja-level multitasking. Oh, and like other animals, such as chimpanzees and dolphins, octopuses have proven to be good at maneuvering tools, like picking up old shells and using them as a temporary home. Now, of course, the most intelligent animals on our planet are humans, according to humans. But we don't seem to give pigs enough credit. Pigs are so smart they can play video games. No, not Minecraft. But in a recent academic study, scientists had 4 pigs play a joystick game. They had to manipulate the stick so that the moving ball would hit the wall and then they would get a treat. All 4 pigs did great in the test, which was surprising even to the scientists. Now, pigeons also aced an impressive test. They were trained to differentiate a Picasso painting from a Monet one, which they had no trouble learning. Then they were able to apply this knowledge, identifying works of art they had not previously seen, meaning they really understood the difference between each painter. Poor things are always seen as a nuisance. Now, if we placed kangaroos in an animal's most amazing ability contest, they'd win. It's mainly because they break the 4-legged rule. A special species of kangaroo, the red kangaroo, uses its tail to help propel it forward. Now, visually, it has 4 limbs, but in practice, it uses 5. They're biologically built to use their tail as a 5th limb, since it's packed with articulated vertebrae and thick muscles. Of course, it had to be an Australian animal. Okay, jokes aside, Australia is home to a variety of unique animals, like the most venomous snake in the world. This not-so-cute reptile is known as the inland taipan, and its venom is enough to take down 100 humans. And still, on the topic of dangerous animals, the island is also home to one of the world's most venomous spiders, the funnel web spider, which can be found not too far away from downtown Sydney. Yikes! The Little Mermaid may have shown us that life is good under the sea, but she didn't mention anything about the bizarre ways of the anglerfish. Anglerfish are those special types of fish that have a huge whip nose connected to the front part of their bodies. They look like they're forever holding a lantern in front of them, except that the little lantern they carry is a type of bioluminescence, and is far from romantic, as anglerfish use it to lure smaller fish in as their meals. It was back in 1999 that scientists discovered that these little guys spend most of their lives upside down. They had never seen anything like that. Hovering above the Pacific Ocean floor at a depth of around 16,400 feet, where light almost doesn't even reach, there they were. They do this because since they live so close to the seafloor, their built-in lantern illuminates the ground in search of food. They might be weird, but they're also pretty clever. Recently, scientists have discovered a species of animal that has neither a brain nor a head and is pretty smart. Meet the brittle star. This 5-armed creature is a bundle of nerves, and it has proved itself to be super clever. In a recent experiment, scientists would dim the light while they fed brittle stars their favorite treat, yummy shrimps. After 10 months of conditioning, these babies would creep out of hiding as soon as the scientists turned off the light in the room they were in. Surely they were expecting to enjoy a delicious meal. Now, we really shouldn't judge a brain by its size, or lack of brain in this case. There's something known as the orange cat behavior, and apparently it's not just a meme. So far, scientists have been able to understand that coat color is connected to a feline's gender. And since orange is an X chromosome, orange cats are usually males, like Garfield. The so-called orange cat behavior describes ginger cats as agents of chaos. Again, pretty much like Garfield. However, there haven't been any conclusive studies on whether coat color and cat behavior are truly linked. In terms of vision, mantis shrimps probably have the most psychedelic vision out of all animals. These funny-looking creatures have a whopping 16 varieties of photoreceptors, with 5 of them reserved for the ultraviolet or UV spectrum. Ultraviolet rays are really short wavelengths, which are invisible to humans. The thing science still doesn't understand is how exactly these mantis shrimp view the world around them. Sure, they can perceive a bunch of colors, but they can't necessarily distinguish all of these colors among themselves. It can be that they just see a lot of really vivid, really blurry colors, but we haven't figured out a way to check that out. Now, to say sloths are cute is an understatement. They may be one of the friendliest animals in the jungle, but there's more. If you look closely at their fur coat, you'll notice hints of green. These greeneries are actually tiny little algae that grow alongside sloths. They help sloths to camouflage better in the jungle, but they also nurture them. The little cracks inside a sloth's fur create the perfect environment for algae reproduction, and scientists have found species of algae that don't exist anywhere else in the world. They do get by with a little help from their friends. Deep within the Sahara Desert, you'll find a little creature known as the fennec fox. This huge-eared animal adapted perfectly to survive in its hostile environment. The huge ears help them to dissipate the unbearable heat of the desert, as well as help them to hunt for underground prey. Now meet this guy. Unlike what its name might suggest, the red panda is closer to a raccoon than it is to a giant panda. You'll find a lot of these cat-sized creatures in the Himalayan region, hopping from tree to tree and bundled together trying to keep warm in the harsh weather. They're gentle and friendly like their big panda cousins, and occasionally enjoy eating some bamboo sticks. And then there are bees. Compared to humans, bees' brains are the size of pinheads, yet they are capable of astounding things. Let's say a bee is running low on energy after a long search flight. This bee desperately needs a drop of honey in order to continue flying, but smartly enough, she doesn't need to go back to the hive to recharge. She can ask a fellow beehive mate for a drop of honey directly from this other bee's stomach and continue flying. This type of decentralized system allows them to build highly effective societies, one that bees don't need to push through the queues in front of the honey cells, for example. Hey, just kidding.
About a third of all grown-ups have a snake phobia. But if you decide to become an astronaut not to have to deal with them, it might not be a great idea. According to Story Musgrave, there are snakes in space. Musgrave is one of the most experienced astronauts in the world right now. He is the second astronaut who managed to go on 6 space flights and fly on all the space shuttles. With that much experience and time in space, he has to have 1 or 2 space horror stories in his career. Once on a space mission, he looked out of the window and saw something resembling a snake. Musgrave said it was 6 to 8 feet long and looked like a snake. But many people don't believe his story. They claim it was some trash floating in space or something that had detached from the spacecraft. But the astronaut went on another mission and saw the creature again. The first time he spotted it, it could be some detached piece from the spacecraft. But what are the chances of that happening twice? He gave many interviews in which he explained these crazy encounters. Let's hope those snakes stay in space and don't come crashing down on Earth. If they are real, of course. Snake rain would not be fun. As we all know, space is like a giant vacuum chamber with 0 air, and sound can't travel there, making this story even more terrifying. To communicate, astronauts have a special system in their suits to exchange information. Young Li Wei shared his terrifying experience, and it's hard to believe it actually happened. You would be terrified if you were alone at home and someone started knocking on your door at night. Of course, if you weren't expecting anyone. Imagine the same scenario, but you're in space. You hear some knocking. You have nowhere to run. You're trapped in a metal can, floating into nothingness. Young was sitting in his spacecraft, minding his own business, when he suddenly heard knocking coming from outside. How is it possible? Sound can't travel in space. The noise was unique. The astronaut described it as if someone had been knocking on an iron bucket with a wooden hammer. Li Wei looked outside, but to his surprise, there was nothing there. He investigated a bit more, but couldn't find the source of the sound. When Young returned to Earth, he was eager to tell scientists about what had happened, but he could not recreate the sound. To add fuel to the fire, his colleagues, who were on the same mission from 2005 to 2008, said they had also heard knocking similar to what Young had reported. This is still a mystery. Nobody knows what happened then. Maybe it was just spacecraft noise, like those your house randomly makes. We've already mentioned that sound can't travel in space, but that doesn't stop weird noises. The Apollo 10 mission was one of the most significant space missions ever. So, astronauts had to ensure everything was perfect before they went on a moon exploration journey. 3 people were on that mission: Thomas Stafford, module pilot John Young, and lunar module pilot Eugene Cernan. They had to do tons of gear tests for the upcoming Apollo 11 missions. The astronauts were circling the moon when they heard music coming from somewhere. It wasn't like Ed Sheeran's concert. It was more like constant, loud screaming. Then, it was quiet whistling. They were terrified. Imagine being in space for the first time and hearing weird noises. The sounds lasted for a whole hour. The astronauts had never heard anything like that before. The sound was otherworldly and creepy. When they returned to Earth, they didn't know if they should tell someone about their experience because it was hard to believe. Michael Collins, an astronaut from the Apollo 11 mission, later shared that he had also heard this sound. But there is a kind of logical explanation for this. Engineers from NASA said that the sound that they had heard had been caused by the interference with the communication system. So you can relax and throw your tinfoil hat in the trash. But before you do that, Al Worden, an astronaut from the Apollo 15 mission, said that this explanation was unlikely, so we might never find out what really caused the sound. Leroy Chiao was the commander of the International Space Station in 2005. When it comes to space, he's seen a lot of things that can send chills down your spine. One encounter he and his crew had will live on in their head rent-free forever. Chow was sitting in the space station doing his job when he suddenly spotted light from the corner of his eye. He took a closer look, and it resembled an upside-down V, floating and glowing in space. Leroy later explained that he hadn't been scared by the object. Quite the opposite. He was extremely excited to see it, even though he had no idea what it was. His crew also saw the strange object. Chow was convinced he was visited by something not from Earth. His team could also vouch that indeed they saw something unexplainable. The information about this encounter is all over the internet, and many people are skeptical. It could have been anything. There are more than 10,000 satellites in space right now. It could have been a satellite floating in space. Another theory is that those were lights reflecting from a fishing boat on Earth. But who knows? There may be another logical explanation for this phenomenon waiting to be discovered. Horror stories don't stop there. This one is hard to believe, and it's up to you to figure out if it's true. Astronaut Alan Bean was the fourth individual to set foot on the moon's surface. When he was on the Apollo 12 mission, he claimed he saw a unique shape on the moon. It was shiny and shaped like a shoe. It's hard to know what he saw because he passed away in 2018. Chinese lunar rover Yutu 2 also discovered some shiny substance on the moon. Scientists say it was something gel-like. It could be a glaze that formed when something impacted the moon's surface, like a meteorite or something else. But in the future, we might find a better explanation for this strange find. This may sound wicked, but many countries send animals to space before humans follow them. Take Miss Baker, a squirrel monkey, Ham the chimp, and many more. Many of these animals returned to Earth safely and lived happily ever after, like Ham the chimp, that lived for 26 years. But some weren't so lucky. Astronauts are still creeped out when they see animals floating in space. Imagine seeing something like that in a dark vacuum. No matter how tough you are, after that, you will be afraid of your own shadow. This may be sad, but it was an essential step in space exploration. The following horror story comes from space engineer Musa Manarov. This guy came across something that made scientists confused. He was shooting a video of space when he accidentally filmed some shiny object flying in the distance. The thing had a cylindrical shape, and Manarov thought it was something that had detached from the spacecraft. But he was unsure because it moved in a unique way. When you think of a creepy space story, the first thing that comes to your mind is some creature crawling on the spacecraft, or some weird object flying in space. But all those things are highly unlikely to happen. When somebody asked Chris Hadfield what the scariest thing about space was, he said it was asteroids. There are thousands of them in space, and the spacecraft is constantly getting hit by them. Chris said that he'd always heard sounds from asteroids hitting his spacecraft. He also mentioned that the spacecraft's solar panels were covered with holes. And you never know whether a giant asteroid will come and hit your spacecraft.
We often see humans living on other planets like Mars. Colonizing our solar system and beyond has long been a dream of humankind. The idea of humans going to space dates back to at least 1610. A German astronomer named Johannes Kepler wrote to an Italian astronomer named Galileo. Kepler said that we could create ships to travel in space, and even create maps of the stars. People got more excited about space during the famous space race. NASA was created in the 50s. They did many cool things, like sending space stations, Mars rovers, and exploring other planets. All this made space travel seem more real. Today, we've developed to the point where we finally discuss the possibility of space tourism. We're already sending regular people into space. Only very rich people, of course. But many believe that, in just a few decades, space tourism will become normal. We'll be able to fly to Earth's orbit and back, as if on some kind of tour. Spaceships will replace airplanes, and it will only take 2 hours to get from Australia to England. And finally, we'll begin to travel to other planets in our solar system. Some scientists even believe we'll have colonies on the Moon or Mars by the 2060s. In the future, we could colonize not only Mars, but some of the moons, like our own, Ceres, Titan, and others. But the thing is, why do we even want to live on other planets? Surprising question, huh? Sure, the answer might seem obvious at first glance. Humans want to learn about space and other planets. This curiosity is what led us to other big discoveries like going to the Antarctic and the Moon. Next, safety, of course. Humans have a moral duty to ensure our survival. Colonizing space could protect us from disasters that might wipe out life on Earth. Plus, by settling space, we improve our chances of survival and fulfill a moral obligation to do so. Besides, with Earth's overpopulation, colonizing other planets could relieve the strain on our home planet. Another thing is, colonizing a planet means living there and using its resources. And let me tell you, there are lots of resources in space. Our solar system alone has things to use for fuel, like Titan. Space colonization could bring us clean energy, access to new materials, new technologies, and so on. The more we colonize space and learn about it, the more we could benefit humanity. More technology, more exploration, more innovation, and so on. History also says explorers are way less likely to get into fights. Expanding and exploring, scientists claim, keeps us busy with cool discoveries, growth, and research. The more we explore, the less we're stuck with our earthly problems. But on the other hand, not everyone is interested in going to space. And maybe colonizing space isn't as good an idea as it seems. First of all, is it even possible? Some people say that living in space is just too far-fetched. You might have heard about terraforming. Terraforming basically means changing and improving the planet however we want, as if we were in some character maker in a video game. Sounds great. In theory. In reality, terraforming Mars, for example, could take hundreds of years and cost millions of dollars, according to experts. Colonizing our moon could cost an unimaginable $104 billion. It's 7 times NASA's yearly budget. And that's not even counting the earthly costs. But the biggest, most important question is it really that cool to live in space, though? Space isn't your cozy home at all. Most celestial bodies are radiation hotspots, all because of the solar winds. Imagine a wind so fierce that it can strip planets of their very atmospheres. Our sun is a real danger to each planet in the system. Yes, including our own Earth. Stars are crazy powerful. They shoot out charged particles all the time. These particles can zoom around at incredible speeds, going up to 5 million miles per hour. These gusts of particles can leave an entire planet all barren. Poof. No more life-sustaining air. The water on the planet would evaporate, then freeze. The temperature would plummet to very chilling. And even daytime skies would be as black as night. Lucky for us, Earth has an amazing shield called a magnetosphere. It protects us from these space winds. But scientists are studying these winds to help us find other friendly planets out there. By checking out stars' properties, gravity, and magnetic fields, we can see if their planets can truly host life. And it's very hard to find a planet that isn't showered by radiation all the time. It has to have a very thick atmosphere, like on Earth, to prevent this from happening. Unfortunately, we haven't discovered any planets like this so far, which is why living in space would mean dealing with crazy health problems. Temperatures and radiation are just the beginning. What about muscle loss, troubles with vision, and many other things? Humans are way too vulnerable for that. Robots are more suited for space exploration due to its hostile conditions. Let's take Mars, for example. The red planet is freezing and very uninviting. In fact, the Earth could face almost anything, even mega problems, and still be better than Mars. Mars is a desert with barely any water, very far from the idea of a dream home. Let's imagine that the Earth's air get polluted. Mars still wouldn't be better. The air there is super thin and 96% carbon dioxide. Earth's air is a cakewalk compared to that. Or even if a huge asteroid crashes into Earth, we're still better off here than on other planets. It might even be a pretty big asteroid, like the one that wiped off the dinosaurs. This event was absolutely catastrophic, plunging the Earth into utter chaos. It created a massive crater called the Chicxulub crater. The impact led to massive fires, tsunamis, and a lot of dust and debris flying into the sky. The dust and debris blocked out the sun for a long time. Can you imagine what happens when there's no sunlight at all for a while? Everything got really cold and dark. This darkness and coldness affected plants and animals. Without sunlight, plants couldn't make food through photosynthesis, and that meant many animals lost their source of food. And these were only short-term consequences. Of course, many species became extinct because of that, but even with all that, 25% of species managed to survive somehow. If this same asteroid had hit Mars, the outcome would have been much worse. Mars doesn't have enough things like water and air to support life like Earth does, so the consequences would be way harsher. Actually, the Earth survived not 1, but 5 mass extinctions. And life still managed to thrive on our planet, even after all that. As you can see, it's almost impossible to make the Earth completely inhabitable. Our planet will always be the most habitable place compared to anywhere else in our solar system, unless we do something extremely insane. Which is why we need to protect it. Here we come to the famous "the Earth's in trouble" argument. If something bad happens to our planet, why not focus on fixing it instead of flying away? Critics argue that if we can't take care of Earth, we shouldn't spread our problems to other planets or moons. Are we really capable of responsibly colonizing other worlds if we can't even manage our own? Plus, there's still so much to explore even on our own planet. Humans haven't even lived in Antarctica or under Earth's oceans yet. Are we sure we're ready for worlds that are even more extreme than that? So, even if Earth gets into trouble, we shouldn't just ditch it. We have to work together and create safe zones. It would be a big challenge, sure, but it's still way more doable and cheaper than building space colonies. Of course, the idea of humans living in space and traveling to other planets is very exciting, but we should never forget our sweet home, and we should remember that life isn't science fiction. We should use our technology rationally and focus on making the Earth safer and better. And what do you think about it?
Picture this. You're planning your dream holiday, but instead of going to a tropical beach or a bustling city, you're thinking about going to space. Imagine yourself floating, weightless, looking down at Earth from a whole new perspective. The beauty and wonder of our planet become even more evident when you're viewing it from a distance. And now, this dream can come true. Yes, you heard that right. Space tourism. Space tourism is something that has fascinated people for generations. This idea has been around for almost 20 years. We've seen it in movies and read about it in stories. But now, thanks to advancements in technology, it's finally becoming a reality. The first space tourist was a businessman named Dennis Tito. He visited the International Space Station in 2001. Sounds incredible, but here's the catch. Tito's trip cost a mind-boggling $20 million. That's a lot of money, and it made space travel seem like a dream that only the super rich could afford. And it's true that space tourism can be quite expensive. But a lot of time has passed since that day, and now space tourism is becoming more attainable for people who aren't billionaires. Of course, the industry is still in its early stages, but the demand for it is skyrocketing. Pun intended.
Experts believe that it will continue to grow at an incredible rate of around 40% every year from 2023 to 2030. So, with all this in mind, let's talk about what awaits us in the near future. There are different types of space tourism. First up, we have suborbital spaceflight. It's the trip where you reach an altitude of over 300,000 feet, which is way higher than any airplane can go. In fact, it's so high that you cross a special line called the Kármán line, which marks the boundary of outer space. How cool is that? So it's basically like a quick jump into space and back. So let's talk a bit more about suborbital spaceflight. Imagine you want to go on vacation to Sydney, but you live in London. Normally, it would take you about 22 hours to get there by plane. That's a really long time to sit on a plane. But guess what? Scientists and engineers are working on a new way of traveling that could make the journey from England to Australia super fast and exciting. Suborbital space trips could be used for quick travel between different cities on Earth. Instead of flying in a regular airplane, you would hop on a spacecraft that can go really, really fast. According to a recent study, in the near future, it might be possible to fly from London to Sydney in less than 2 hours. Just imagine how amazing that would be. You would zoom up into space, see the Earth from above, then come back down in no time at all. What an adventure! This study, conducted by the UK's Civil Aviation Authority, was all about understanding how our bodies react to trips outside Earth's atmosphere. To figure this out, the researchers needed some brave volunteers. They recruited 24 healthy people between the ages of 32 and 80. These volunteers were taken to a special training facility called an RAF centrifuge in Cranwell. A centrifuge is a big machine that looks like a giant spinning chair. The volunteers were sat in there to experience a simulation of spaceflight. They were spun around, and their bodies felt the pressure and changes in gravity that happen when you go into space. Almost everyone handled the simulation pretty well and quickly returned to normal. One person even briefly lost consciousness, but it was because of the gravitational forces, and they recovered soon after. Now, this study found some surprising things. Many people think that you have to be really fit and young to handle space flights. But the research showed that older people can actually cope better with all this gravity craziness. So even if we don't develop space tourism in the next decade or two, you'll still have a chance to visit space even when you get old. Right now, there are two big players in the suborbital spaceflight game: Virgin Galactic and Blue Origin. Both of these companies have rocket-powered systems that can take up to 6 passengers on a thrilling ride. Virgin Galactic has already had 4 successful flights, but they recently ran into some financial trouble. On the other hand, Blue Origin has flown 32 passengers on their new Shepard rocket. The catch is pretty obvious. Right now, space tourism is super expensive. Companies can charge a whopping £350,000 per seat for these flights. But don't worry, things are about to change soon. Experts believe that space tourism will grow in the coming decades. It will be kinda similar to what happened to airplanes. Right now, the cost of a quick trip to space is very high. But as time goes on, the prices will go down. Eventually, space tourism will become more affordable and accessible to people all around the world. That means not just our children, but many of us will have a chance to experience the wonders of space. As technology advances, we might even be able to plan rocket-powered holidays in the future. Can you imagine telling your friends that you went on a vacation to space? What a flex! And now, let's talk about orbital spaceflight. This is the real deal, where you get to spend more time in space. Instead of just a few minutes, you can spend anywhere from a few days to over a week up there. And we're not talking about a measly 300,000 feet anymore. We're talking about going over 1.3 million feet high. So whether you're up for a quick jump into space or a longer adventure orbiting our planet, space tourism has something for everyone. Sky is no longer the limit. But space tourism isn't all fun and games. There are some challenges we need to consider too. First off, let's talk about the environment. Launching spacecraft and rockets takes a lot of energy and can create air and noise pollution. This can seriously harm our atmosphere. We don't want to trade a cool space trip for a damaged planet, right? Next, there's the issue of safety. Space travel is still risky, and accidents can happen. Even with safety protocols in place, there's always a chance of something going wrong. And if it does, the consequences could be really, really bad. Yikes! Space debris is another concern. Every time a spacecraft is launched, it leaves behind debris that can stay in orbit for a long time. As more launches happen, the amount of debris keeps growing. This can cause problems for other spacecraft, and even small pieces of debris can cause damage. Space travel also requires a lot of resources like energy, fuel, and materials. Using up these resources too quickly could have long-term consequences for our planet and future generations. We need to make sure we're not depleting everything in our quest for space exploration. Oh, and let's not forget about all the legal stuff. The rules and regulations for space tourism are still evolving, and it's not always clear who should be responsible if something goes wrong. Plus, there are concerns about how space tourism might affect international space laws and treaties. We don't want legal chaos in the final frontier. And finally, to achieve our dream of taking spaceships like planes, we'll need better infrastructure and logistics. We'll need to build more spaceports where spaceships can take off and land. But don't worry, scientists are actively working to solve these problems. Remember, it's not just us who are excited about space tourism, even governments are joining the fun. Many countries are investing in space tourism too. It's a global phenomenon. So even though there's still a lot to develop in this industry, it's pretty obvious that the aviation industry might go through a big revolution. Traveling long distances would become much quicker and more exciting. And judging by the way development is going, the first big breakthrough in this area will be made in North America. So, get ready for a new era of travel. What an exciting time to be alive, right? The universe is calling, and it's time for us to answer. Stay tuned! You get the last instructions from the team and get into your spaceship. It's the first spacecraft made on Earth that can move at a speed close to the speed of light. Your task is to visit the most unusual and terrifying places in space and send scientists detailed information about them. And so, your journey begins. Your spacecraft is accelerating, and you dash past the moon. In the distance, you see a small reddish planet. It's Mars. And look at that spectacular giant surrounded by a set of rings. That's Saturn. You wish you could have more time to explore this gas giant, but you have to hurry. You pass by beautiful stars. Some of them are luminous, others have a reddish hue, and some seem to be dimming. That's Sirius, the brightest star in the night sky on Earth. It's about 8.6 light years away from us, but you're traveling fast, and soon you see Polaris, aka the North Star, which is way further, 431 light years away. Sometimes you manage to spot tiny dots circling these stars. Those are planets. And then, suddenly, you see nothing. At first, you're horrified. Something has gone wrong, and you've accidentally entered a black hole? Has your equipment malfunctioned? Because it seems that at a distance of 700 million light years away from Earth, there's a hole. A blank void with no galaxies, stars, planets, or asteroids. You can't see anything. The void is a roughly spherical region of about 330 million light years across. Our home Milky Way galaxy could fit in there billions of times over. And then it dawns on you. What you're looking at is the mysterious Boötes void. It lies about 700 million light years away from Earth in the constellation of Boötes, the herdsman driving the plow around the North Pole. At first, this void was called the Great Nothing, but later it was given its current name. Now we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters, but between these clusters and threads, there are ginormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Boötes void is one of the most massive ones. It's even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, all the matter in the universe was packed together quite tightly. Astronomers even think it was something like a uniform soup. But pretty soon, random quantum fluctuations started distributing this matter. Some areas became denser. As a result, their gravitational pull became stronger, and they began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. After staring at nothingness for some time, you decide to explore other space objects and start the engine of your spacecraft again. There's one kind of space formation you've been looking forward to seeing: nebulas. Those are gigantic clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. Sounds familiar, doesn't it? One day, this mass becomes so big that it collapses under its own gravity and forms new stars. So, you decide to visit some of the most beautiful nebulas out there. And you start with the Butterfly Nebula. This butterfly's wingspan is more than 3 light-years. And the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 450,000 degrees Fahrenheit. It means it was formed from a gargantuan star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass or a butterfly. The next place you decide to visit is the Eskimo Nebula, 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and got its name for a reason. Its double shell formation looks like a person's face hidden in a padded hood of a winter jacket. But in reality, this parka is a disk of material with a ring of comet-shaped objects. And the tails of these objects stream away from the star at the center of the Eskimo Nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. As for the Eskimo's face, even though it resembles a ball of twine, in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Your next destination is the Ring Nebula. At first sight, it's a giant cloud of dust and gas surrounding an old, almost extinguished star, which does look like a ring. But astronomers say the nebula isn't a bagel, it's a jelly-filled donut. The deep space colorful object more than 2,000 light-years away from Earth is actually a ring that wraps around a blue, ball-shaped structure. Each end of the structure sticks out of the ring's opposite sides. Now you can head to a place called the Pillars of Creation. You find it more than 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars just 5.5 million years old, space babies. Once, the Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. And now you can see them with your own eyes. Those are the so-called Pillars of Creation, an active star-forming region. And since you've already visited a star-forming region, why don't you drop by a living fossil galaxy? For example, DG-SAT-1.
It's as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It can mean that DG-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. The next stop on your space sightseeing tour is the Black Widow Pulsar. Just like its spider namesake, this rotating neutron star is munching on its partner, a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. Oh, look at this! That's a stellar nursery in the constellation of Centaurus. But even though this place might be called nursery, it's anything but peaceful or safe. This region, made up of hydrogen and newborn stars, is located in a nebula in the constellation of Centaurus, around 6,500 light-years away from Earth. The intense energy these baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful that it's eating away dark clouds of dust, and they're disappearing like lumps of butter on a hot frying pan. You're continuing your journey when you see something absolutely amazing, a cloud of water floating in space. To be more precise, it's a cloud of water vapor surrounding a supermassive black hole 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself.
Traveling to space costs a fortune, but there's a way to make it affordable. You step into an elevator, push the button, and voila! You're flying to the stars, all thanks to nanotubes. But then something hits the elevator on the way. You're stuck inside, and now you're doomed to float in space forever. Now, if you want to travel in space, get ready to shell out around $55 million. But in the near future, you'll probably be able to travel to space with just the push of a button without breaking the bank, because space elevators might come into play. While the idea of galactic lifts seems like something out of a sci-fi movie, it is a real possibility that could revolutionize space travel. With an estimated cost of $8 billion, space elevators could be a one-time investment that would last us forever. NASA alone spends around $2.7 million on rocket fuel per minute. To launch a rocket, they need to pay up to $178 million. These costs could be significantly reduced with the use of elevators. Most super tall buildings on Earth have a massive foundation to help with their balance and weight. As you look up, they get thinner and thinner. Even the tallest building in the world, the Burj Khalifa, is massive at the bottom and narrow at the top. If we wanted to construct something like a gigantic lift, we would need an enormous amount of concrete to build a foundation for it, which goes against the point of saving some cash. Now, get a string, tie a ball at the end of it, and start spinning it. The string in your hand will stay in one place, and the ball will revolve around your hand. This is called centrifugal force, and the elevator will work in the same way. The ball will be the base in space, and the rope will hang toward Earth. The station from where we would enter the elevator would be in the middle of the Atlantic Ocean, and the line would extend from there. For this to be possible, the line must be perfectly synchronized with Earth's rotation. Otherwise, it would simply break or wrap around the Earth like a scarf. Also, the orbit the line would be following should be a perfect circle, because the line wouldn't be able to get shorter or extend. A bunch of research has been done using algebra to find the ideal solution. Wait a second, there's a use for algebra? Never mind. Meanwhile, I won't bore you with the math. We'll go straight to the point where the precise distance from the station in the Atlantic to the one in space must be 22,236 miles above the Earth, where the geosynchronous orbit starts. There, the four outward forces are much stronger than the downward force. That's why the station would stay in one place. When you construct a house or a building, you start from the bottom going up. But to create this engineering wonder, we would need to do everything in reverse and start at the top. The main problem here would be the weight. If the line was too heavy, it would disrupt the orbit, and the conveyor dumbwaiter host would not work. So we need to balance the station in space to ensure it worked flawlessly. Steel is one of the most robust materials on Earth. The cable in every lift is made from steel. But when you need a 22,236-mile-long cable, things can get tricky. Steel is hard to break, but it's cumbersome, and when you have to use a lot of it, problems start to arise. We use heavy steel a lot in construction, but we have lighter materials that might put less stress on the station and eliminate this problem. Also, the line would have to be tapered because, at the endpoint, there would be close to zero stress. But it would still have to be thicker than really needed due to a bunch of safety factors. At the start, the rope would be around 0.5 inches. After using some complicated math, we can figure out the thickness at the end, which is a number so long I am unable to pronounce it. But believe me, it's a big one. So, steel is off the list. Another candidate is Kevlar, which is 5 times stronger than steel. And if we added such materials as carbon and titanium into the mix, the strength would increase tenfold. The line would have a diameter of around 262 to 557 feet. This is drastically smaller than the diameter of the steel cable could be. The bad news is that doing this is too pricey. So if we don't find the ideal medium to build a cable, the idea of the space elevator will just be a massive waste of time. If only we had some magically light material with a power of 60 gigapascals, which would have a taper ratio of 1.6. Oh wait, we actually do have this unique material. It's called carbon nanotube. It has a strength of 130 gigapascals, which is much more than we need. Nanotubes are made out of carbon and are 100,000 times thinner than a human hair. This material is solid and has good conductive power, which is possible thanks to its unique atomic structure. We use this product in many things, from batteries to optics, and it can be modified entirely and adapted for more uses. Bradley Edwards is the guy responsible for this crazy idea. NASA was looking for new innovations, and they said, "Don't do anything too crazy and start building a space hoist." I guess Bradley took this as a challenge and started working on the elevator. Edwards wrote a paper about a galactic conveyor. When he published it, he expected many people to find flaws in his work, but surprisingly, nobody did. His work was spot on. He came up with the idea of strapping a nanotube line to a rocket and launching it into space. The other end of the rope would fall onto Earth, and robots would use this rope to climb up and make it longer, so we could start building an elevator space station. After this, the elevator could start transporting everything, from solar panels to tourists. In the future, space tourism could be totally possible. Who knows? We might even go on vacations in space. Hey, looking for some atmosphere for your getaway? Well, don't come here. We don't have any. Oops, probably not a good advertising slogan, huh? Meanwhile, a couple of years ago, we could only create microscopic carbon nanotubes. But as time went on, much more research was done to make them bigger. Now they reach up to a few inches. In 20 years, they could be miles long. Carbon costs $28 per ounce. If we do the math, we would see that we would need around $1 billion to build a lift. Yeah, it sounds expensive, but it's a long-term solution to space travel, and it can actually save us a lot of money in the long run. Now, everything looks perfect on paper. But NASA's main reason why they chose not to go along with this project is that right now, there are probably more than 128 million objects floating in orbit, and they might pose a real threat to the elevator. The lift could be made to withstand a few hits now and then, but getting hammered non-stop is not part of the plan. Still, Bradley argues that tons of monitoring devices track space debris. Thus, the elevator could avoid them all. Now, if something hit the elevator or the line somehow broke, the consequences would not be too bad. If there were no passengers on board, of course. If the line got cut, the elevator would simply float away into space, posing no threat to people on Earth. In Japan, engineers are trying to build a space elevator. The lift could be used for space mining too. We could easily cover the cost of the entire elevator by collecting asteroids, because some of them are made of expensive metals. We could mine them and quickly bring them back to Earth.
Buckle up, fellow space enthusiasts, because we're about to uncover the celestial secrets that have been unveiled this year. From giant stars to organic molecules, this year is going great for astronomers. So let's catch up on all the excitement you might have missed in 2023. First of all, we've discovered some real astral monsters. Imagine looking up at the night sky and seeing stars that are not just big, but absolutely enormous. Scientists have been using a special telescope called the James Webb Space Telescope to explore the early days of the universe. And during their adventure, scientists stumbled upon ancient stars that are 10,000 times bigger than our sun. Yes, you heard it right, 10,000 times. These giants of the stellar world were some of the very first stars ever to form in the universe, billions of years ago. Imagine a globular cluster as a massive cosmic crew, where each group consists of a whopping 100,000 to 1 million members. These clusters are like giant family gatherings, with all the stars being born around the same time. But what makes these newly discovered monsters so special? Well, their cores, or their central parts, are way hotter than what we see in stars today. Scientists think that this intense heat might be due to a lot of hydrogen burning at really high temperatures. It's like they're having a galactic barbecue party. Something fascinating happens in these globular clusters. The smaller stars crash into the supermassive ones and gain extra energy, like a power-up. But here's the twist. Most of these clusters are now getting old, and the supermassive stars disappeared a long time ago. We can only see hints of their existence in the clusters we observe today. Scientists study them by just the mysterious traces of their grand presence. The discovery of these monster stars is incredibly important for our understanding of the universe. If scientists can gather more evidence to confirm their existence, it would be a major breakthrough. It would help us learn more about globular clusters and how supermassive stars form in general. But that was only the first fascinating discovery of 2023. Although the next one is kinda sad. You know those beautiful rings that make Saturn look so fancy? Well, guess what? They might disappear in the not-so-distant future, astronomically speaking. NASA's Cassini mission, which explored Saturn from 2004 to 2017, gathered some fascinating data about the rings. During Cassini's grand finale, when it did some cool maneuvers between Saturn, scientists noticed something surprising. The rings were losing a lot of mass every second. Tons of it. That means this magnificent halo will only stick around for a few 100 million more years, at most. That may seem like a long time for humans, but in the grand scheme of the universe, it's just a blink of an eye. The important thing is that we've learned that huge rings like Saturn's don't last forever. They eventually fade away. Oh, well, at least you and I personally won't catch this moment. Scientists have a fun theory about what will happen when Saturn's rings disappear. They think that the other ice and gas giants in our solar system, like Uranus and Jupiter, might have once had massive rings too. But over time, those rings wore down and became more like the thin, wispy bands of asteroids like what Uranus has now. Saturn's rings are mostly made of ice, but they also have a sprinkling of rocky dust. This dust comes from asteroids and teeny tiny meteoroids crashing into the celestial objects and breaking apart. It's like a snowstorm of icy particles and space debris. The research also revealed that Saturn's rings appeared long after the planet itself formed. They were still forming when dinosaurs roamed the Earth. So, in terms of astronomical age, they're actually quite young, only a few 100 million years old. This discovery has got scientists all excited because it means something dramatic happened in Saturn's past to create this stunning icy disk. But this is a mystery waiting to be solved. Scientists want to figure out what exactly caused the rings to form and why they have such a breathtaking structure. Let's hope they'll figure it out. But moving on to something more optimistic, we have another exciting space news. Recently, scientists have been studying one of the most distant galaxies in the universe, and they found something amazing: organic molecules. The galaxy in question has a long name, SPT 041847. It's over 12 billion light-years away from our little blue planet. Can you even imagine that distance? It's the farthest galaxy ever known, where complex organic molecules have been found. That's why looking at this galaxy is like looking at something from when the universe was just a baby. We have no idea what this galaxy looks like now. The light that has reached us is what it looked like when the universe was only 1.5 billion years old. Imagine being able to see things from so far in the past. So what they found is something with a very complicated name: a polycyclic aromatic hydrocarbon molecule, or simply PAH molecule. You might be wondering, what in the world is that? Well, guess what? You can actually find these molecules right here on our planet. They can be in things like the smoke from car engines or even forest fires. PAH molecules are made up of chains of carbon atoms. And here's the super cool part: they're considered the basic building blocks for life. Imagine that, life's building blocks, those tiny carbon chains, being discovered in a galaxy that's so far away. That's like finding a needle in a haystack. They also found out that gas floating around in that galaxy is filled with heavy elements. That's a big deal because it suggests that many stars have come and gone there, creating all these amazing elements. This means that this galaxy can be potentially rich in many other elements too. This discovery opens up a world of possibilities and raises so many exciting questions. How did these molecules form in a galaxy so distant? And since we're looking into the past, what could have happened to these organic molecules during this time? Could they have evolved into life? We're only scratching the surface of the incredible things waiting to be uncovered. By the way, if it's so far, how did scientists even manage to discover something like that? Well, they had the instrument called the James Webb Space Telescope. This fancy telescope was recently launched and has superpowers when it comes to observing the universe. So when the scientists were studying this faraway galaxy, they had a little problem. The light coming from those distant objects was so faint that it was hard to see or detect. But guess what? They had a brilliant idea to solve this. They used something called gravitational lensing, which is like a special power of nature's magnifying glass. Imagine two galaxies lining up perfectly, just like in a photo shoot. The light from the faraway galaxy, the background one, travels towards us. But on its journey, it passes through the foreground galaxy, which is like a giant space lens. And guess what? The foreground galaxy's gravity bends the light, just like a magnifying glass, making it bigger and brighter. It's like having a cosmic zoom lens for our telescopes. This bending of light creates a super cool shape called an Einstein ring. It's like a halo, or a ring of light surrounding the foreground galaxy, basically a nature's way of showing off its magical powers. With gravitational lensing and these beautiful Einstein rings, scientists can see distant objects more clearly and learn amazing things about the universe. And thanks to all that, they managed to uncover the hidden chemical interactions from the early galaxies. Isn't that incredible? The scientists are beyond excited about this discovery. They never expected to find such complex organic molecules in a galaxy that's incredibly distant. Who knows? Maybe this is just the beginning of a thrilling cosmic journey. So, keep your eyes on the stars, fellow space explorers. The universe is full of surprises, and who knows what other mind-blowing discoveries await us out there.